Start up YouTube. There we go. YouTube has started. Give that a couple seconds to propagate. Once the software realizes I'm doing stuff. This over here. We'll just put this back together real quick while we're starting up. I must always be productive. No, I really wasn't productive over the past couple days. I've been mostly brain dead. There we go. Modular testing. Module testing module, working on the module, power supply module. Pop out the chat. Pop out chat. It's muted. Give that a close. There we go. Okay. We should be pretty good. I don't have any moisture here though. That's a problem. I'll get something midstream. Okay, so where are we? Did a little bit of work on the power supply in order to get all of my ducks in a row for today. I have a panel that fits all three of the voltage and amperage modules, and we have somewhat of a plan. We have a little bit of a plan on what to test for the negative voltage reading and the negative voltage current, so that we can have a plus-minus power supply and everybody will be happy. And we'll have crosstalk between the power supplies. These are still a little bit loose. I could have tightened up those XY tolerances a little bit, but I'll go over them more when we actually get to using them. So those go there. I was thinking about if I wanted to have all the electronics on the back panel of this thing and have the back panel like hinge out. That'd be kind of fun. All right, so we got to put these things back. Ow. A sharp circuit board. They really didn't anticipate that being handled at all. Other than that, other than, you know, retro brighting these things, I wasn't really up to much. They don't look that shiny. They're not. There's like a bit of a tinge on them still. It did do a lot, I think. Probably made them a little bit more brittle. It may need like another treatment if I want to get them like pure white. But I guess they are called ivories, so. Now, what keys fit where? I did not keep track of that at all. I would assume one's the cut on the side, it goes somewhere like this. Oh wait, E4, E4, E8. So they do have markings. Oh, and there's actually a lot of crap down here that I won't get to unless I clean it right now. It'll never get clean unless I do it right now. Oh wow, they have little rubber bumpers on them too. All right, let's get a paintbrush or some kind of a, maybe a toothbrush. Yeah, toothbrush will do. We'll just get crap all over. Don't forget to brush your keyboards, kids. Brush your keyboards every day for good gum health. Yeah, toothbrush is a very good tool to have in the shop. It just blasts away grime with all the features of it. Just a nice analog toothbrush. I'll brush backwards here. Maybe that'll keep all the rubber from flying out. But I'm just breaking off the grime. Even though it doesn't really affect the use of the keyboard. Just be good to know that it's clean. All right, that's a little better. Now my toothbrush is full of crap. Ugh. Nasty, it's other people's grime. People are disgusting. Ooh, I'm not gonna have any viewers because I haven't streamed in a while, and it's Wednesday. It's not a typical stream day today, so there's gonna be low numbers today, but maybe it'll lead to a more normal Tuesday. I think that's probably the direction that everything's going. I just lost another rubber thing. I gotta watch out for these things. These little rubber dudes like to fly away. Am I missing more? Oh. That one doesn't have one. Keep our eye out for little rubber thingies that fall off of this thing. Oh, I guess the ones on the bottom face differently. How does that work? I wish I could actually hear what was going on with the mix. I guess the mix is very low. I'm going to bump it just a little bit. What's up, Kenneth Hayes? Your check is in the mail. my one viewer is I guess that went over there. Yeah, so that worked. That one gets closed. That's the old one. Okay, and then what am I doing? I'm looking to turn up the volume on the music just a little bit. This is a Deckard chill mix on Space Cowboys Ripecast. Well, you know what? It should be a little lower than that. Your boom leg shot. Ah, okay, yes. How's it going? Okay, so that's not supposed to be there. There's already a bumper there. So one of these is missing a top bumper. The one on the end. Well, I should have guessed that. Bonk. There's that one. That's a little bit greasy. Okay, so let's get these back in place. Where the hell? What the fuck? All right, that one either goes all the way on the end. I think this is where this one goes. This one goes here. And that little snappy thing snaps into the snappy thing there. Oh yeah, okay, so that goes in the rubber bumper thing, and then that snaps in here, I think. That's how the key moves? Wait, but the key moves against the total bottom piece, so I'll get this eventually. Ah, like that. Okay. So it goes all the way where the two you can't see anything. Two bumpers, and then this thing fits all the way in. Low to the surface, and then that snaps in like that, and then there's our key, and then the key action is down there. We'll do the springs in a minute. All right, first one, I need a black key on the left, so I guess that's an E7. It's all the way like that. Yeah. There you go. Clunk. And then we have one on each side, and I guess that's this one. You see the cuts for the keys. I've ever put a keyboard together on this level. Although this isn't a very high level. Oh, there we go. Okay. Cut on the... That's a big cut on the left. I think we need a small cut on the left. Big cut. Big cut. Do we only have big cuts? This one's both sides. There we go. So that one's both sides. There we go. And then this one is only on one side. It seems like a kind of a big cut for that. Is that gonna fit? Yeah, that's gonna fit. Okay, so that's what goes there. It's just all informed by the black keys, huh? It still looks yellow. It still looks very yellow. You guys maybe don't see it because of the camera's color space that it's in right now. I do kind of warmer tones for this stream, but these are yellow. The horror. Although they're ivories. They're called ivory keys. Bother. What's your problem? Yeah. That's on both sides. Oh, see, this one has like a big cut on one side and a small cut on the other. What would that be? Wouldn't be there. Wait, uneven cuts. Oh, look, this one's got a huge gap right there. So this is wrong. Ha! This one has a thicker one on one side and a thinner one on the other. This is a puzzle. Has some yellow keys on my Yamaha, one's near the edge close to the window. I used RetroBrite. I bought the $20 thing. It seems like it needs more than just one session. I think one session of RetroBrite, which is 4 hours in the sun, with all the goop sprayed on it, is not enough. Oh, this key doesn't fit here. Wait a minute. Probably doesn't fit there. Ooh, I'm sweating already. Is this the wrong key? Does that one need to be bigger? I don't think that's the case. Let's see what other keys I've got. That one's only on one side. This side. Both sides, but one is vastly thicker than the other. Same thing, it's the same type of key. And when this one goes in here, there's a big gap. Oh, no, there isn't. Wait a minute. That's perfect. That's the key. Although that gap's a little weird. The keys are not individual. They're all connected together at the rear. Wait, how does that... You got to be able to take them apart. Are they plastic? Let's see. Thin on one side, thick on the other. Should probably fit in here. There's still a bit... That's a big gap. That's not right. I can get you out of here without hurting myself. Ow. I guess that's my answer. That one has one on both sides, so that's a thin. But I don't have a thin. The only one that's thin is this one, and there's a weird gap above it. But this one also is surrounded on both sides. This one has that there, and this here. There's no gap. That's kind of a big gap right there for that one. I don't think that's going to do it. We'll go here. Well, that fits with little gap, although I think they're colliding with one another. Is that the way they're supposed to go, though? This is a strange puzzle indeed. Octave-long modules worth of white keys and 2 black key modules per octave. I don't know how to conceptualize that in my brain. But the spring is integrated into the key. So if you use RetroBrite on it, it might get a little bit brittle. And I don't really experience that with these because these have an external spring. And you know, there's no internal bending except for maybe that pin right there, but that pin doesn't bend all that much to hold the key in. So it's possible that you'd run into problems. Where in the world? I wonder if I could find what the key layout designation of the M Audio MIDI controller is, so I could get it right. These seem, there's like 4 different key types, but they're pretty individual fitting. Like that goes there because there's a key above it. So that's a definite yes. Same with this one. That goes there because there's a key below it. This one is up in question. Get all my questionable choices out of here. This is also a questionable choice. Yeah, let me just fill in the ones that are kind of like known first. Yep. That one's below. Just reduce the volume of keys that I need to deal with. We're using logic. There's a huge gap right there. There's nothing you can do about it, I guess. Ooh, I'm sweaty. I guess it's subversively warm today. It's not hot out. There's a good breeze, but I'm in a basement, so things tend to lag the weather outside. So I'm oh, this is not the right kind of key. So I'm sweaty down here. I can RetroBrite it, but I don't want to. I think it's okay for the keyboard that I've had for 25 years to look a little aged. I suppose it's just like this thing looked like it belonged to a smoker, so I feel like I didn't have a choice. Plus, I wanted to try RetroBriting something. I don't get that many opportunities. Embossed on the underside. Nah. These do have a marking. It says E4 up at the top here. What the hell is that? That's here. And so here's the marking. It just says it's just blasted out. It just says E4 on it, right? But E4 is this individual type of key. So this E4 is going to have the same marking as another E4. So here's the E3, E1. Here's another E4 right here. So this one's an E4. This one's an E1. Wait a minute. So there's E1 and E4. Interesting. Well, that's why we're doing it this way. I mean, I get to figure out which ones go where. Wait, I have an extra E4. Maybe E1 goes away. Because this one's E1. This one's E8, E7. E1, E4, big gap. E3, E7, E3. Ugh. I think it's like, what key is this individual key? Oh, sweaty. Okay. Well, I can try to a 2-octave key set. Yeah, I don't know too much about musical stuff, but let's see what we can look up. Audio MIDI disassembly. I don't think anybody cares enough about this thing. We used to have one to control our fire cannon setup. There's a hammer. There's a picture of a hammer. Here's an iFixit. Keys. Nobody bothered to mark them. I can't see the labels. We can see a little bit over here. Let's get a picture of just the layout. Oh my God, this is torture. You can see how evenly the gaps are on all this. Okay, removing the springs. Nobody made any effort to tell us what the order is. Ah, it's funny. Tools using the step. Tweezers. Yes, okay, thank you. Nothing else. Wow, well, there's an iFixit, but it's not useful in terms for figuring out what keys go where. I mean, I could just use it to have a picture of the keys sitting in the thing. Is there going to be enough glare here for us to actually see what the E markings are? These look like a different version of what we have. See, there's just E and G. So these have markings for the notes. Ours don't have that. Ours is just E1 through 7 or whatever. And there's repeats, so it's not reliable. I mean, E8, 7, 6, 5, but that's not really going to be what it is. Technically, this says E6. So I'm going to put E6 here. See, and then there's that gap. This one's also E6. 8766. But then that collides with the one below it, so that's not correct. This one's E5, which miraculously fits. E5, technically this would be 4-3. So that one's a 3. Is there an E4? E4 is entirely over on that direction. And it fits. E4, E3. But would we go back to E5 for that one? That's E2. Okay, this makes sense. If it's 2 octaves. E2. And this one's 4 and 5. So probably need like another E8 or something. Because we got 8, 7, 6, 5, 4, 3, 2. And then we're back to 4, which is not correct. 0x30 months. Wait, what's this sub? Hey, Mahalo. Okay, so these do actually have an order to them. Hey, Mahalo and Bridgewater. Mahalo has 60 months of subs. Mahalo, thank you so much. I really appreciate you here. I'm glad you're getting something out of this. A Bridgewater, 0x30 months, as in 48 months. 1 to 7, 1 to 7, 8. So we'll start at E7 after E1. If I can find E1. A Bridgewater, thank you so much. 48 months is nothing to sneeze at. Nor do I feel allergic. So let's see if we have an E. Here's E1. E1, and it happens to fit right here. Okay, so it's E. It is marked. These are marked properly. I almost got them completely out of order. It was a fun puzzle when I didn't know. I had fun with it. I'm worried that my fingers smell a little bit like clay after working with this. The problem is one of my grandmothers was big into clay. She did a lot of clay work, and she smoked a lot. And so this is like memories of my grandmother smelling clay. I might actually just be smelling cigarette smoke in this. That's probably what yellowed the keys in the first place. So E7 is the next one to go in. For 7. And 7 is the right kind of key. Look at that. E6. E6. E number 5. That's E1. E4. E2. Is it under here? Yeah. There's E5. 5. 4. 3's already installed. One of the few that I got right. 2. Ah. And then 1. All right, now for the springs. This is like, the problem is this thing down here is all of the through-hole components, and this thing's like a fucking cheese grater. This thing will destroy you. It's very sharp. It's got its own little microcontroller. Keyboard RUD event. What does that even mean? I don't know what RUD is. I don't know what it is. There's only one, E8. All right, so now I got the springs back on. The springs are pretty easy to do. They're just kind of a weird design. It's just this little like, well, it looks like a dildo, and it's just this little spring that you can put on with just a thing to push down on. Oh, rapid, oh, yeah. Keyboard RUD. No, it was this is a planned disassembly, and the purpose of which is to refurbish this keyboard and make it function again. Basically, I got this thing off of eBay, and it was pretty dirty. It might have been outdoors, or it might have just been through a smoker's house, or I don't even know. It's just not led an easy life. So what we've done is taken all of the stuff out of it, and then I used a little retro bright on the keys in order to make them look okay again. And it's done a little bit for it, not much. It seems almost like it needs another retro bright session. But I don't want to do that. I'm lazy. Yeah, this would be construed as maintenance. See, these little things are the shape that they are so that they grip the two cups that they're supposed to fit into, and then I can easily install them just by poking them with a screwdriver. And I'm going to put them on the keys first. All right, do you think, man? Do you think? Good to have you here. Don't let me stop you. I guess I didn't even need to take the knobs off because those didn't come off during disassembly. They are part of a sub-assembly that fits into the front of the thing. What's up, Flatulent Gonad? How you doing? Yeah, my grandmother smoked, and I was always very familiar with that smell. It smells like a clay shop. So the smell of clay and smoke, cigarette smoke. But I think these are more on the clay side of that smell. Definitely the clay side of that smell, though. That's weird. Maybe a very residual tobacco smell I interpret as smelling like clay working clay. Maybe that's what it is. Maybe that was never a clay smell. I've always misinterpreted it. We're missing a spring. I'm missing a spring. I've already found out. Where's the spring that I'm missing? Missing a spring. That's trouble because I don't really know where it could have gone. I will have to take a close look in just a minute. I'm like super sweaty today. I don't know what it is. I think it's just that the basement lags in temperature from what's going on outside because it's perfectly beautiful outside. So I'm going to try not to move around too much today. These are an easy install too. Look at this. Yeah, the iFixit was of a gray back piece, not black, so let's redo this one. This must be a later model. At least the things are labeled. You know how easy this is. And this is the missing one. All right, so I need to find one more of these weird Springo things. Enjoyment of gourmet hot sauces. I bought some of the Hot Ones hot sauces, and it turns out that celebrities are weak as fuck. They are so weak. That last dab using Super Duper Pepper X is shit. It's painful sauce. It's too peppery. I don't mind the flavor as much. The other Hot One sauces were really good. I got that 3-pack, the 3-pack of sauces. They're way overpriced. Their ancho chili is trying to be a different ancho chili sauce. It's trying to be that other sauce that they used to have on the show, which you can get off of Amazon for much cheaper. So I will be buying more of that and not the Hot One sauce. Their buffalo sauce is pretty even-bodied and well-flavored for a buffalo, and it's got a buttery creaminess to it that I really like. But that X sauce, the last dab, is way overrated. It's not a delicious hot sauce. It is a pepper sauce that has super-duper pepper in it, but it's not that super-duper hot. And I would assume that's because they prioritize flavor, which is fine by me. It's just the reactions of all the celebrities to that sauce are protracted. I can understand how Conan survived rubbing it all over his body. Because I put it in tuna salad and it was kind of just nice. Oh, I don't care about the hot sauce community. I'm not connected to that. Boy, it's so nice. It's so nice to be a fan of something and not interact with the fandom. It's just nice. You're just like, this is great. Ed Curie's sauce. I don't know the name. No, I don't want to know anything that's going on in the hot sauce community. I have a bottle of Pepper X oil. It comes in a dropper, and it's pretty doggone hot by the drop. It would be something you add to like a big chili, but it's too chemical tasting because it's probably extract. Extract has too much of a like chemical awful heat. I like the natural heat of something. We're talking about a thing that Gonad will never ever experience, being in Britain land. Potato is probably slightly too spicy for him. I'm talking smack and he's not even here to listen. Or maybe he'll hear. You mentioned the hot sauce and Hot Ones, yeah. It's I mean, like, I don't mind the Hot Ones hot sauces. I think their lower heat stuff is good. I think they maybe copied some other hot sauces flavors. You know, like the ones that got lots of compliments. But some of them, they're not hot. They're not that hot. It's funny because, like, well, they hit you with that, like, what is it, the bomb sauce? And I'm sure that's one of those ones that's just torture. It just probably hits you way too hard, and it makes you sweat for a little while. But I thought that the last dab would have been a bit more of a challenge than it was. I've only tried the mild maple one. That sounds pretty good. Yeah, a little maple flavor. Maple goes a long way, though. Maple will tint the entire rest of the tasting experience of whatever you're having. And if it's chemical maple, if it's that sort of like what I call food science flavors, like, one time I got a McDonald's maple breakfast thing, and it was just food science maple. It was like my tongue was programmed ahead of time to taste these things. But good maple from up north, oh, hell yeah, that's good stuff. We used to get New Hampshire. Actually, I have. This one's, I think, from 1992. Oh, no, where'd it go? I moved it. Okay, it's not there anymore. I have a little tin of maple syrup that's from New Hampshire, and it's from 1992. It looks like a little cottage. It's hilarious. Let me see here. We're missing a spring, and we've done stuff with silver things all week. Well, I haven't streamed all week. All last week and the week before, we've been doing stuff with things that look like the color palette of a spring. So theoretically, it could have gotten almost anywhere on the bench, which is not good because there's a lot of nooks and crannies on this bench. And I need this one spring so that I can finish this up. I can put the M-Audio MIDI thing back together, and then I'll have a MIDI keyboard to use with the synthesizer. Closest tap, New Hampshire sugar maple to me is maybe a few hundred feet away. Awesome. Yeah, we would stop at like the roadside things that would pop up around this time of season when the maple was popping. I'm looking for a spring. Hold on. One missing spring. Where is my spring? My spring. If I dropped it and it bounced somewhere, I'm in trouble. Things are usually pretty tame. They stay kind of close by. Oh my god, there's like barges of dog hair. I have to clean, I have to vacuum. I must vacuum at some point. It's been a little while. Huh. The other place it would go is somewhere on this desk and just be kind of under stuff. But I was sizing out all the different modules that are going to make up this module tester, so I've got stuff all over the desk. We're going to work on the power supply today. The power supply is a nice jumping off point for the rest of the build. Power supply sort of supports everything else, and we need certain functionality out of it. So I've built a panel that has all these meters on it, and those meters will help us measure how much current is being used. How did that get on the floor? And so I'll be able to plug in a module under test or two. Hold on one sec. The air dried out, so I guess all the allergens found it. Oh, I feel like I'm sinking in dog hair, huh? Last dab is not that hot. It's not as hot as I expected it to be. Like if it was on a chicken, I can see how Alton Brown got through all of them without even breaking a sweat. I mean, his mouth must have been torture at that point because you're trying a lot of different crazy sauces, but they do fade out pretty quickly. And the last dab is just kind of disappointing if you're acclimated to a mild level of heat, as a chef probably should. I see no little dildo-shaped spring anywhere. Darn it. This is not good. I was careful with them. I tried to keep them all together. Let's see if there's one in here hidden around. You're discussing some of the highly controversial subjects over the last year, and that is Pepper X. Yeah, I don't get the hype around Pepper X. They make it sound so scary on the label, and I was like, all right, well, I guess I'll just be careful. And I put a couple drops of it on some tuna salad, and I'm like, okay. I mean, that was hot. It's peppery, but it wasn't. Oh, I just saw it. There it is. Good. But yeah, it seems like the hype is really strong. Like, their ancho sauce is very, very good. It's very overpriced. And you might as well just buy whatever the ancho sauce is that they used to use, because that one is more widely available and it tastes the same. It's basically just an add-on to like a taco. It's a good add-on to a taco, though, because it has a lot of really good acid in it, and it's sort of this beautiful bouquet of peppery flavor that doesn't overwhelm. It's like not really that spicy. It's more of a tangy sauce, and it's really, really good on burritos. This is a good song. I like this song. I'm turning it up in my ears. If it's what I think it is. I think it's what I think it is. YouTube viewers are not hearing the music. I have to qualify that every time. Not the song I thought it was. This is a different song. It makes an big steppy. Okay, let's go over here. Kind of scamming people with this product. I'm not saying it. I'm not saying it, but I am saying, I am pointing people towards the other sauces that are a little bit better. Or the same thing as the ancho chili sauce, or whatever. Not chili, but ancho pepper sauce. It's, you know, you want to get a basis of comparison to the rest of the hot ones. Line up and see how kind of terrible celebrities are at hot things. And I realize now how Conan O'Brien didn't go to the hospital after rubbing it all over himself. I wouldn't recommend doing that. It was probably a massively painful experience, but not as, like, just abjectly insane as I thought it was. All right, I got a bunch of screws. I got to get those in. I'm kind of crushing all these circuit boards while I do this. It really does smell like my grandmother's clay shop. This guy to explain the whole controversy is John Scoville from Chase the Heat Johnny. We went after Ed and his product. He sent the last dad to the lab and had it tested. Getting labs involved, huh? I'm actually going to use the auto screwdriver. This would be a good application for it, because otherwise I'm going to tire out my hands, my beautiful hands. Oh, Lord. There we go. Okay, so proper bit. Big electric screwdriver. Does this thing magnetically hold on to it pretty well? Not at all. Well, at least we got that over with. I'm not looking to blow my mouth up. You know, I don't really want the super hot sauce. I don't want to use it. I don't want to have it. My phone just got the notification you're live. Yeah, things lag sometimes. Phones can be unreliable in their message queue. Yeah, super duper omega hot sauce is not my thing. It's just not my thing. But, you know, if I'm buying Super Duper Omega Hot Sauce from the Super Duper Omega Hot Sauce show. I want it to be a Super Duper Omega Hot Sauce. I don't mind heating the sauce, but I'd rather, you know, I don't need to keep talking about it. There's something you'll never hear a streamer say. I don't need to keep filling content with this. Gotta love soulful ambient. It's my favorite genre. Does this fit in here? No. Okay, so now I can't use the electric. Crazy hot stuff, more to taste and heat. Well, everybody is. If you talk to anybody about hot sauce, that's what they say. It's just that everybody's level of that is at a different point. And if you've been eating hot sauces for a long time, or you haven't had a comfortable butthole in months, then you're going to be acclimated to the stuff that's insane. And so those sauces that seemingly don't have any flavor to you will have flavor to other people. Did I not screw down a circuit board? No, everybody is screwed down. These are just these little screws that hold in the rest of this thing. Oh, Lord. Actually, the last interaction I had with an M Audio MIDI keyboard was at a festival in Maryland, and what the purveyor of the, I guess, exhibit, if you would call it, they had a, I think it was a couple wire spools, so it was just like this big round table, and they had various accoutrement around it that were all synced up with one another. They all had the same rhythm going on. And so one of the keyboards, and the one that I poked for a little bit, it just had samples on it. And so you could press one and it would go, "Oh Lord, won't you buy me a Mercedes-Benz?" And it was all synced up with whatever music was playing. So you could, with a bunch of random people, do a whole ensemble if you really wanted to actually push the buttons at the right times. It very much trivialized people who make music. You people are babies with your electronic music instruments. You're babies with a little play school thing. Hellfire Hot Sauce Company. Look, man, I'm not going crazy. I said that before. Using the screwdriver to probe whether or not there's a screw in there, because I can't peer all the way down to where the screw is. So I put the screwdriver in and I back up and I go back a little bit. And if I don't feel it engage in anything, then I know that there's no screw there and I can insert one. Those are enthusiasts. There's a sauce from Hellfire called Fear This, and it's a fantastic sauce on pizza. Interesting. So I've been, my pursuit over the past couple months, actually for a while now. It's been a while, and I have been saying, I really want to try a proper deep dish Chicago pizza. There's just nowhere that provides that sort of thing around here. It's just not the kind of thing I can get in the food desert that I'm in. But it turns out that if I sorted my delivery place by most popular, this thing came up immediately, and it was a Chicago deep dish pizza place that was willing to send a driver all the way out to where I am. I didn't test this one, and there's already a screw in it. It felt wrong. Yep, there's already a screw. How about you? Nothing. So I got it last night, and I bought the whole pie, and I'm like, that's kind of expensive. I guess delivery is getting really expensive. You know, having pizza for the first time in like 6 months. Order the pizza gets here. It looked like it wasn't that much food. And I'm like, yo, that's where the money's going these days. There's just no, you don't get a lot for what you pay for. And then I open this thing up and it's a goddamn humongous casserole. This thing is like, it's this thick, mostly bread with like sauce, just kind of spritzed on top of it with the cup pepperoni, and then cheese as a crust around the square pizza. It was, in fact, an entire family's meal, not just me. I had like one slice of it, and the rest of it went to the fridge for everybody else to pick at for the rest of like the month. But it was just this greasy like casserole. Not even like a casserole, it was just like grease bread. It's insane. absolutely psychotic. I want, you know, next time I get pizza in like November, I'm gonna get just like a cheese pizza. I'm just gonna get a cheese pizza, like a normal cheese pizza, not some abomination of grease bread. All right, Oxygen 8 back together. Does it look better than when it arrived? I don't know. I actually don't know. I can't tell. The ivories look ivory. They look consistently ivory from tip to tail, though. They do look consistently ivory, although they do look a little. Oh, it's a little. You got a little creakiness to some of the keys. I might have to lend a little bit of grease to the hinges. I don't. No, Long Dog. I don't want that. I don't want a tour of hot sauces. I don't want that. I don't want it. I know you can provide it. I don't want it. No, it's called being a fan of something without interacting with the fandom. And it's one of the best things in the world. Listen, I very seldom buy hot sauces. I have a couple bottles going at a time right now. You know, my friends can be kind of crazy with hot sauces. I have one friend from college who has signed the waivers for some, and some of them are like sealed in wax, and it's like, I don't want to blow out my sensory perception that fucking hard. I'm happy just buying like a little bottle of hot sauce here and there, trying it out, having a couple opinions, and moving on with my life. I am glad that you love the hot sauces, but I'm not looking to get into another hobby that's going to cost me a bunch of money, because I seem to be doing that too much lately. I have a few too many hobbies going on right now in my life at all times. What was the Kimba song? Oh, no, this keyboard's broken. What's up, Matabue? How you doing? I gotta remember how to play the piano. I took lessons as a kid. And then I sung in high school. So I kind of know how to read music on sort of like an amateur level. But I don't really remember how to play. Still got my note spread, though. 1, 2, 3, 4, 5, 6. How do you count it again? It's 1, 2, 3, 4, 5, 6, 7, 8, 9. It's almost a 10-note spread. Cool. Okay, well, that's the M Audio thing back together. This thing can go back into the background. This would be my source of MIDI that I could put into the tester to create 1 volt per octave signals. All this stuff, the record, all this stuff, useless. I don't need it at all. All I need is beep coming out of this thing, which we may have to program a couple sequences of 1 note per octave things that'll sync up with everything else. I don't know exactly what I'm going to be doing with that. That's musical, and basically the software on this tester scares the pants off of me. My pants are scared off, and I don't know what to do. But we're taking baby steps towards the fruition of hardware to function, and that will allow me to jump into the programming purely and have a platform that I'm going to put all it. All right, taking song requests. Yeah, play us out. What does that even mean, play us out? Fucking thing sucks. Yeah, I don't know what the notes I'm hitting are. I'm pantomiming. I am pantomiming hitting chords. But I used to play. That's not to say that I was good. All right, this thing probably still has chemicals on it that are getting onto my hands. It's a real chef for somebody who knows how to make sauces other than vinegar. That's why I like the Alton Brown's Hot One episode, because he actually criticizes them on a pretty deep base. Well, on an informed basis. That's pretty much where it is. All right, let's put this over. How's my light stand? It's my mic cable's always threatening to get pulled. I won't fit there. I'll just put it right here for now. Where's the power supply for it? That's over here. I haven't even turned it on yet, but I don't have a MIDI input yet. Need to either look at a Hajiwo project or finish this module tester module, which is a big project. Big project. All right, so this is what I worked on. Pull this out in a minute here, and we'll do some haphazard testing of it. And hopefully I don't blow any of these things up. I'd be very happy to not blow any of them up. And then let me get my information up on the screen here. There's a reason why the section of my Discord specifically for talking about stream projects is really supposed to be laser focused on that, because I will pull diagrams up from there. So it's kind of like my organizational notebook. So that's this diagram, which is beautiful because it's on a whiteboard. There it is. There it is, beautiful. That's beautiful. Only I have one thing that I think is not correct. It's that the plus 35 volts is sensing off of the negative load. And it's somehow going specifically to the positive load. It doesn't make any sense, because that's not, you can't isolate that. Everybody's going to be sharing grounds, at least for the synthesizers, that's what happens. So 7805. I'm not using a 7805. That's one thing I'm not doing. Although, wait, they are regulating. Am I going to have to do that? Am I going to have to throw it in? The venerable 7805. I have bins full of them. This is not like, okay, so the 7805, I'm not a huge fan of, but it's not like with me and 555s. 555s are completely obsolete and they shouldn't be used anywhere. You should have to program something in order to output pulses, because that is a stepping board to much greater things. That is my argument against the 555. I think learning the 555, getting everything done with the 555, that's all well and good, and that's fine and skillful if you're into that sort of thing. But if you're talking to somebody who's new to electronics, we're done with 505s. They're done. Their era is over. We are no longer using them for that. Get an AT Tiny or something similar. Now, you can say, oh, but they're so expensive. Well, how much does a 555 cost these days? Because they're certainly not used anymore. Let's see how cheaply we can find one. They are crimes. They are all individual little 8-legged crimes. You son of a bitch. $6, $2. Like $2 for a bunch of them. $1 for an AT Tiny 85, $5 for 2, 99 cents to $3. I don't believe that. If you buy them in super bulk, they're very cheap, but you can get a programmer for $4. So you jump into the AT Tiny and you learn how microcontrollers shuffle their brains around, and you can do everything your 555 timer does to a degree. And I'm sure there are corner cases. There are always corner cases. But I've seen a 555 using an analog VCO unit. Yeah, it's called the one sec. It's called the something a phone. Where is mine? Mine was over here. It was right here. I swear I had it. Where'd it go? Little bastard. Oh, I had an instrument over here that was a VCO. Well, I mean, it was the whole deal, but it was the VCO in it is a 555, and you're completing circuits to different capacitors. 555 is so useful. No, it's not. No, it's not. It's completely obsolete, and you shouldn't be bothering with that sort of thing anymore. What's it called? This is a David Bowie instrument. The something a phone. The sousaphone. No, not the sousaphone. Damn it. My example's gone. Oh well. All right, let's get started. Hammer and dulcimer. No, you're just naming stuff. All you need is a NAND gate, and you can build anything. Stylophone. There you go. Gorillaz had a song about it. Or was that? No, that wasn't. Why did I hear stylophone in the lyrics? I don't think they said that at all. Anyway, I totally misrepresenting everything I talk about. Listen, if you guys need to know anything about narrative and literature and the unreliable narrator, like, you're looking at it. That's what I am. I spread misinformation on the internet. Everything that I say here on stream should be taken with a grain of salt, and I mean like a sea salt grain, like one of the ones that's like a giant crystal that you have to bite into and it really hurts your teeth. Like, that's the kind of salt that we're talking about here. So, yeah. So anyway, the projects that we've been working on, I haven't been streaming for a little while. There have been just some life things to sort out, and, you know, feeling whether or not I'm up to actually streaming and stuff. Turned out to be a pretty big gap between streams, and I don't generally mean to do that. It's just things come up. There have been a lot of crazy things happening in my life lately, and things will settle out in a bit. They're already starting to settle out a little bit. So, you know, like, if I can't stream, I will let you guys know sometimes at a moment's notice. But I apologize, and it has been weighing on my soul that I need to continue to work on these things because I got to get stuff done. We haven't gotten a lot done. Now, I've been doing a lot of background work, things that I can sort of put on in between, you know, getting other things done, like helping run the house has been kind of a big deal lately. So, you know, I'll start a 3D print, go do something else, come back, you know, etc. Go vacuum a room or something like that. But what we've been working on is a module tester module. It's a workshop, not a done shop. My nephew asked me, if it's a shop, where's all the stuff you're selling? And I'm like, It didn't, the psychic hit was too much for me to tell him that it is a workshop, not a commerce shop. But I didn't have the wherewithal because it sort of pulled the rug out from under me. Questions from little kids are always just really biting. Anyway, so we haven't gotten a lot done, and that's been weighing on me. We have been doing the mother of all yak shaving things, which is to try to fix Dave's 303, try to tune my own synthesizers. All of it leads back to having to do a module testing module. And so we've looked at how module testing modules work, and we've come up with a design that's a little bit more malleable than the other ones, and it uses one of our cool-looking screens. As such, I don't think it's going to be all that flashy. I'm not sure about how much we can display images on this thing. If we can do an oscilloscope readout, that would be nice, but I don't know about the speed of the VFDs, and I know the phosphor takes a minute to calm down after it's been activated, so it might not oscilloscope all that nicely. That said, we'll still be able to measure a bunch of stuff with this thing, and so I can do tuners and things like that. And maybe if the mood strikes me right, I could design stuff that looks a little bit better than just numbers on a screen. Although numbers on a screen look pretty cool coming off of this thing. So in order to put that together and use my sort of cool screen, we needed a very solid 5-volt source. So to get a solid 5-volt source in a modular synthesizer, you need only rely on the 5-volt power supply that I don't have. USB is not enough to power this thing, so I can't just plug in the microcontroller and start futzing with the screen. My power supply, my Agilent, really nice, accurate, I'm stuck. I gotta call my stepsister. Okay. In order to get my really nice Agilent power supply pooping out the right poop, basically it can do plus and minus 12, and then it has a 6-volt source. So that's a whole bunch of hullabaloo that I can do from there. I don't really want to do that, though. I don't want to have to do that. We will do that today in order to test this thing and make sure that we can get it running right, but I want to have an entire power supply inside this thing. I want to plop this thing down on the desk. I want to put a module into it. I want to plug cables into the module, and then I want to go through and activate the different channels and be able to send it like a gate signal and you know, all that stuff. Send it a tempo, send it audio on any of the channels, and you know, low frequency oscillators, audio signals, high frequency oscillators, all that jazz, gate signals and things like that. All those wonderful things. But I want to be able to just have this on a desk. So like I could take this to Julian's house and work on some of his stuff there, and tune an oscillator of his if I need to. So what I'm going to do is I'm going to put together a power supply that is sort of individual for this thing. Now, in order to do that, we need plus and minus 12 volts. We've got 15 volts coming in DC, and then I bought these things. And these things are, they're just DigiKey things. They're not the full power things that I used for my actual modular synthesizer uses parts from, parts from Mahalo, parts from Pololu. Mahalo was the company that owned Hackaday. I don't think they still do. But anyway, so these CUI incorporated modules create plus and minus 12 volt DC from a DC input. It's up to 9 to 36 volts, and they can produce 12 volts out of it, up to 250 milliamps. So 250 milliamps is way over the top for a modular synthesizer. It is enough to power all of the internals from my stuff at 12 volts. We will then take the positive 12 volts, turn it into 5 volts, and then send it off on its way both to our screen and the rest of the entire design. So we have two of these things. One of them is going to be our isolated internal power. One of them is going to power our whole module. And so this is where my module testing module becomes assimilated into this. It can no longer be its own, excuse me, independent module. Although, one sec. God damn. The weather dried up around here, which is great, but I have all kinds of residual Dagobah swamp in my lungs. This thing I could make into its own standalone module, and it would be pretty cool to do that. I would define a circuit board as the size of the entire module and see if I could fit everything into the same thing, like all this stuff into the same, all into one big package with a printed circuit board. But that would take time and a lot of 3D models that I just don't want to have to worry about. And I'm not selling this thing, so what I'm going to do is I'm going to keep this as the panel with all the stuff on it. I don't think I'll put extra circuit boards on here, although, you know, it would probably behoove me to do that, to put output connectors and a circuit board with maybe the port expander on it, and maybe the circuits for the LEDs will all go on this board, and maybe an extra board on top of that. And then down here, I'm going to have a big stack of circuit boards. So I'm going to have the power supply board and then maybe one or two other boards that are stacked up on top of it that'll be shoved into the corner. In order to make sure that a module is functioning properly, a big component of that is that the power supplies are not shorting out through some electronics. So I need to have the plus 12, the minus 12, and the positive 5 volts monitored. I need to know how much current is going through so that I know if there's a runaway current event and I need to just turn this thing right back off. So, buzzing and noise, we'll get there. We'll get there. We don't need to think about that right now. We don't need to think about that because I've got dog shit put together right now. So just let me work. Let me work. So we've got 3 modules here, and these are all very specifically stated to only work with positive DC current. Now these are sort of cheapo power supply modules you can get off of Amazon and eBay and stuff like that. We were able to find a CAD model from GrabCAD so that we could size these things properly. You can see it wiggling a little bit there. That's just because of the clearances that I've added, and there have been 4 or 5 prints of this panel in order to get this right. That little bit of wiggle should be fine. I can take it out either by crushing the plastic near the edge, like if I use a pin tool and I push down towards the edge, it'll bow out the plastic a little bit and create kind of like a thing that'll hold it together, hold it in place. But, oh my God. But I'm not going to do that yet. We're still in the, you know, sort of the testing phase. All those prints are with gray filament. That's cheap enough for me to get lots of. And so as I iterate through this design, as we need more or less features, we'll at least keep those parts malleable. Those will eventually, you know, those problems will eventually get solved. But I did do a lot of work with this panel here and getting all the dimensions right. So it's just tweaking the numbers until things fit properly. It turns out I don't need, oh God, I hate it when it zooms this slowly. I don't actually need this cutout here to be, like, I might not need it at all if I really wanted these to fit totally tightly. This panel's kind of weak though. I have a bit of a cutout. The problem with that cutout is that basically over here is where it would be making contact originally. I now have it making contact here, and as I move out like that, it gets loose. So these tabs aren't really doing anything. But the creator of this module used an LCD, like, numerical display that is just sized to what the size of this module is. So when you actually go to put this thing into the panel, and it's not a sheet metal panel, even if it is a sheet metal panel, I would fear for the sheet metal panel, because these things are not, they don't flex inwards. They hit up against that display, so they don't move at all. So they can damage my panel. But so I worked on the gap of that a little bit and moved it in. Maybe in future prints, I'll tighten this up a little bit. We'll see where that goes. Or I can just work it after the fact and just, you know, hit it with a pin tool. And that'll create just like a bump in the plastic. That'll just kind of give it a little something to pinch it in place. That, or, you know, push comes to shove, if you build something like this out of metal and this is like your last chance, nothing is malleable at that point. You've removed enough material. Introvert sub mode. Madam, thank you. On the side, you know, don't let anybody see, but thank you for subbing for tier 1 for 5 months. I appreciate that. Okay, you go out there, sport. You get them. I don't want to pull too much attention to it. Anyway, so here's the back panel. Like, let's say you built this out of metal and you've removed material and you can't put material back on the metal. What I would do in this case is just put a dollop of hot glue on two sides or one side. That hot glue is just going to kind of hold it in place to the degree where if somebody pokes it, if they're trying to like find out everything that's wrong with your device and they try to wiggle the panels, so they can go, oh, you got the size wrong because the panels wiggle. It won't wiggle. I have a friend who every time he gets in my car, he starts going through all the stuff that's terrible about what's wrong with the car. And he's like, this is my favorite game. And I'm like, this is the worst fucking game you play, and I wish you would never get in my car ever again. Like, it's the worst game that somebody can possibly play. But yeah, so anyway, we've got the panels mounted. That should work pretty well. The question is, in spite of the listing saying, what? A shop? I don't know how to do that. E-shop, meaning barn or stall. Only became a word as a store in 1764. Huh. As usual, it always dates back to France. It's the same thing with aluminum and aluminium and alumium, which is what we should all be calling it, is apparently dating back to the French. All of these little controversial things that the French have no stake in these days. Okay, so those are mounted. The problem being is the listing for these things. We didn't have much information. Let me just pull this up real quick. Let's do this window over here, and I'll go to Amazon. Whoa, caps lock. Let's see. Yeah, that's out of view, but I need it even more out of view because that's my orders page. I don't want you guys seeing that. Somebody got like a towel rack. What the hell? Okay, let's see. This one. And then this is what I ordered. This little guy. Display voltage and current simultaneously in different colors. Red for voltage, blue for current. Current is measured in the negative rail. The current is measured in the negative rail. 2. Require external power supply with reverse connection protection. Ground wire testing and power supply terminals. The same wire. Quick refresh about blah, 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 blah. So this says measured in the negative rail, huh? Oh, that's weird. Wait a minute. I can't use this at all. Aw, shit. That changes everything. Yeah, that's not good. Because we have positive 12, ground negative 12. We have to do major modifications to this thing in order to measure this properly. That's the detail that I didn't get when I ordered these. I didn't read in enough, because this is somebody that was using the same thing in order to measure positive and negative load, but they split it up into two different negatives. And we can't do that in the synthesizer because all the grounds are connected at the synth. We need something that measures the positive rail current. How do you do that? Can we convert this thing? Let's take a look at what the chip is that's used in it and see if we can extrapolate further on the design here. It's possible that we could modify it, but push comes to shove, I may have to get shunt amplifiers, because I wanted measurements on the positive rails, huh? Back to Blob City. I don't know. Because if I do current shunts, then I can have the shunts on it. I'll need another microcontroller to read, and then I'll need some kind of another display to display, and keeping the complexity down, maybe that would be another. I wouldn't want it to be another VFD, because those have kind of a lifespan to them. Oh, what an annoying thing. Okay, let's just take a look at what this chip is. Because yeah, this whole thing snaps together. Let's snap it apart and let's just take a look at what's in here. Listen, don't make guesses here. All right, so this just snaps in. What the protecting plastic is still on the display. I wonder how many people are running these without knowing this. You really need to peel this off before running this thing. Oh man, pop open your current meters, everybody. All right, so back end of this thing, we got a little adjustment there. We have a scratched off IC, don't we? Oh, that's really disappointing. I wonder if that's a microcontroller then. Because here we have the shunt resistor, and it doesn't look like there's any specific shunt amplifier, unless Q1 is a voltage regulator. And the power is going to pin 1. Where's ground? Ground's coming from this here. And I don't think we have room for any components under the display. So it's going to be a fairly simple circuit, which is why these are so cheap. Are any of these missing? Do any of these have markings still? I thought PICs got their power from the middle. I thought that's what PICs did. But yeah, if it's a PIC, then we're up Schitt's Creek, basically. But does the PIC have analog inputs that are good enough to do shunt measurement? I don't really think so. Ah, what a waste of money. Yeah, they're all scratched off. I can't believe it's a negative side measurement. How's that even a thing? So we've got our shunt, and then we have some supporting electronics, capacitor, resistor. We have the probably analog reference pin. Let's look up a PIC 16F. PIC 16F. Lots of different types. Yeah, something I would have expected like a shunt amplifier in there, like an ASIC. I can't really find. PIC 16F pinout. Don't PICs generally have crystals too? Oh my God, I just want to look at there we go. Yeah, VDD and VSS being in the middle of the chip is something that I'm used to with PICs. Although we have like 16 pins on this thing. That's not what this diagram is. I'm just trying to see generally. Let's do a 16-pin PIC microcontroller. And it gives me the 40-pin. There's VDD and VSS across from one another, which does look a little bit familiar. Although in this case, VSS, I mean, we see a connection there, so it does seem like pin 1 VDD. And then analog 0, analog 1, and analog 2 are 14, 13, and 12. 11's another analog. And then RC4, RC5, what are you? Pin 4, which is weirdly isolated. RA3 VPP, no, it's nothing. Well, it does appear to be a, well, I guess a microcontroller. What about programmable shunt analyzer? Yeah. Shunt amplifier, sorry. So the INA series is like a little SOT223 part. That's not... I have some INAs in a drawer somewhere. This says programmable, though. Voltage output current sense amplifier that senses a drop of current sensing resistor, vary from 0 to 36 volts, independent of the supply voltage. The device is a bidirectional current shunt monitor that allows external reference to be measuring. Okay, this is not... This is what I would use to build something, but... A device that can recognize chips? Do you have that? Is that a thing you have? I need to close some windows. Not too much stuff open. What the? Oh my god. Okay. This computer is probably very close to a crash. Chip whisperer. Yeah. In plus and minus ground reference, etc. This is, I believe I have a couple of similar things to this, and we could always put together a circuit to use them. I would much rather have it just be sort of its own thing. So I guess we're up Schitt's Creek suddenly. That sucks. I didn't know that these were, because negative is shared. Ground is shared throughout the entire thing. So unless I use one as one of these on the negative 12 rail, that doesn't make any sense, because negative 12 would be that thing. Yeah, it doesn't really. Does that make? No, it doesn't make sense. Okay, so that's weird that they would be like that. They're measuring on ground. Yeah, I wanted to have individual things. Anyway, the point is they've completely obliterated the name of the chip, and so we don't know if it's an ASIC or a PIC microcontroller. We don't know what it's doing, what it's capable of. We don't have suggested circuits from the datasheet. We could look up and see a 16-pin shunt analyzer, but this one also runs a display. So that's why I thought it would have to be programmable. What kind of shunt analyzer do we have that's programmable? And maybe what's going on over here is we're taking that and we are cleaning it up so that the analog reads can happen inside of the microcontroller and not shunt amplifier. I'm used to there being a shunt amplifier on things like this. What a bunch of crap. That's really annoying. All right, back to square one. No, they meant low side. Yeah. Let's close all this stuff. Let me open up... Here. I'll open up the page again. See, this would be perfectly fine if this were a single supply device, but we've got a dual supply, and it just kind of complicates things. So you're not supposed to do direct power supply. And this does expect to be the minus side of load. So you're looking at everything, all the electrons flowing through ground, I guess. Electric car wiring diagram, and then wiring diagram 2. Buck circuit or module, powering the power supply. Wait, what? Plus to minus. What, huh? That's not at all how this thing, wait. And that has an external shunt, which this thing doesn't have. This has an internal shunt. Strange. But yeah, they want you to be on the negative side of things in order to measure. That's not what I want to do. Am I ever going to find a use for these things? Man, they made a big sale off of some dumb guy that didn't look at the parameters of what he was trying to do. But then I found, you know, people talking about how to use these things. Oh, what's going on here? I'm building an amateur radio battery box, and this meter would have been used to monitor the charge voltage and current of the battery. However, the current was off by more than 50% reading, way too low. Oh no. Use calibrated. The adjustment on the panel meter was not near enough to cover the adjustment needed. The meter was only good for reading voltage, which was pretty accurate. The current reading is so bad, this is going to the e-waste bin, and I'll look for another one that'll give me a current reading that I can actually believe in and use. Ooh, wow, that's a horrible, terrible, what is this? Code Rush, how's it going? Look, we've been working, I've been working pretty hard. I haven't streamed in the past couple. What? Murky beats me if I don't raid. Okay. Yeah, Party of 8. How you guys doing? Look, we've been working pretty hard on building a module testing module for the Eurorack synthesizer project that I've been embroiled in the past year. So what we have is Dave's derelict M303 strapped to something that I built on a maker beam. And then we have this thing, which is ever evolving and starting to actually look like a synthesizer module. But it turns out I'm not just going to keep this as a synthesizer module. This thing is just going to be the display. There will be a cable that'll connect it to a bunch of circuit boards that are going to be mounted inside of this box. What that means is that I can plug in the power supply, hit the power button, everybody comes up, and then I can start testing a module instead of having to spool up all my lab equipment. I can still use it with my lab equipment, obviously, but this will just clean things up a little bit. Part of that is having its own internal power supply. And so I bought a bunch of these power supply monitoring modules, these little current and voltage numeric displays. Only we just found out, you know, in a modular synthesizer, in a Eurorack synthesizer, most things are running off of 5 and 3 volts, except you have these plus minus 5 volt standards, or plus minus 12 volt even in some cases. You have these big voltages, and those are coming from plus minus 12 volt supplies. So most modular synthesizer modules are going to use positive 12 volt ground and negative 12 volt. They're going to take just that plus 12 DC, put it through a voltage regulator, and make their own 5 and 3 volts. Even though there's 5 volts that can be provided externally, a lot of modules just don't bother with that. So we bought these current and voltage sensing modules, and it seems like these would be pretty cool. A nice way to sort of skip doing a whole lot of development on, let's say, a microcontroller-based shunt amplifier reading test setup, even though most of our test setup is done to be very kind of scientific and complicated and functional. I decided to take a shortcut, and because I can't read, we discovered that these modules, well, I mean, we just read that they're completely crappy, but also that they are for measuring the minus side. So when you have electronics, you're basically resolving the amount of stuff in a loop. Things always function in loops. So the current on the plus side would be the same coming back on the negative side. And so you measure across that current flow. So as the load is powered and power returns from the load to everything else, you can measure that current on the negative side. That's fine, but that's not good for us because we have a positive 12 volt rail, we have a ground rail, and then we have a minus 12 volt rail. It's maybe possible that we measure the negative with this, but I don't think that's the case. I'm not sure. Well, I have a diagram of people discussing this stuff. It's close in it. Where is that? I have a diagram somewhere. There it is. It's done on a whiteboard of measuring these things. Like the negative rail, I mean, maybe I do use one of these to measure the negative rail. Maybe I do it this way. That might stand to reason. So maybe I keep this part of the diagram. And so our minus 12 volts we can measure using this doohickey. A meter that can read positive and negative currents. No, we need a meter that can just read current. That's it. But it seems like this biased will actually read, because we're going to be powering it off of the other rail. So it won't be powered off of this rail. And it'll be sensing this rail. No, I need to know, because this is a testing device. Analog ammeters. Maybe, I don't want it to be analog. I'd rather it be a nice little digital display. I mean, this looks viable for ours if it is in fact going to be measuring the negative load. If that center one is ground, and we're not measuring on ground because they share that ground. So negative 12 we can sense with this circuit. It'll be measuring the distance between its ground and our negative ground, and that should be 12 volts. That's cool. Thank you, Code Rush. It's been baby steps on this project. I've been very sick of this project, and I would like to get the variety up on this stream and not constantly just be working on the same stuff. So I really need to kind of like get going with this thing and get it to a state. But Lawn Dog, stop it. Jeez. Okay, so that's that. I need to find something that's going to measure the positive current. So let me take a look here. I'm going to do, so I did not know. I didn't look closely at how this thing works. So, all right, back to like a base search. We're just going to do panel mount, equals signs. Okay, panel mount ammeter. Ammerer. Oh, it corrected me. I don't think I trust one with a little coil on it. I don't think I trust that. Voltmeter, DC, 100 volt, 10 amp, current tester, 0.28 inch, 3 bits blue, blah, 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 blah. The circuit is exactly the same. Yeah, we're going across the minus load. Are they all like this? Why are they measuring across ground? The coil ones are okay. Yeah. I got close enough. Hi, RYG. I'm looking for one that works on the positive rail because the ones on the negative rail, apparently I bought 3 of the ones on the negative rail. I probably only need 1 because you can't isolate ground like this. I can't isolate common to measure it in the way that they're doing this here. I would have to isolate positive to get that current reading. I thought that was the common way to do it, but it seems like measuring negative is the common way to do it. So I bought 2 of the wrong thing. Not all that much of a disaster. It's going to cost me, but it seems like a lot of these little guys are reading it across negative. And, you know, these are DC 0 to 5, ammeter for circuit testing, charging battery amp. This would be fun and funny, but I don't think I want to use it. Although you would be able to see the little needle juddering about as things happen. I feel like if we were to be worried about noise, these would probably inject a little bit into the rest of the circuit. They're very fancy looking. That one's only $15. I said current measurement is more difficult because you have to deal with the high voltage. I thought it was because, well, no, I thought that was the way you measure current. Like you put a shunt on it, and so that's a very small resistance. And I guess you have to measure the difference in voltage and handle that amount of voltage. Yeah, I guess you're right about that. Yeah, and there's ways to do it if I built the circuit myself. It seems like this style of ammeter, it's going to be hard to find in a positive version. No circuit involved. That's worrisome. Worked all right. Similar value to the BK precision. A little sluggish. Is there a circuit anywhere? Yeah, negative. Oh. This destroys the meter. Oh, okay. Because of the lack of documentation, you could have looked up any of the other products and they would have been just the same. I destroyed the first one. If the supplier had included a simple wire diagram, I would have given it 5 stars. Red wire, yellow wire, black wire. That should power the device just fine. But now you're putting that voltage into it and it blows up your whatever microcontroller. Is Amazon a good source for that kind of stuff? I have Prime. That's why I use this. We use Prime for a bunch of stuff here. We basically live on top of an Amazon warehouse, so I get things that are shipped like the same day sometimes. I wouldn't suggest that for everybody, and I know that because of the time that I stream, I have a lot of European people who are just entering their evening and would, you know, watch my content, and for them, Amazon is not the solution. In terms of sourcing stuff, I'm not great with that kind of thing. Amazon is just kind of my go-to because of the free shipping. Surface mount device was loose. That is the shunt resistor. Gunite uses eBay. Okay. Yeah, how are the shipping things in your... Because for us, it's just Amazon has its own fleet. All right, so none of that stuff was incredibly healthy. Helpful. Jeez. What's wrong with my brain? 2 days or 3 months. Yeah, you kind of forget what the project is by the time it arrives. I don't like that. At least that's the way I am with AliExpress. So some of them have just the little coil that you put around the thing that it's sensing. They're expensive, but it's a shame. I think all of the ones that use this display are using the PIC microcontroller or whatever microcontroller, you know, whatever that thing is. And it's being used alone. No, that one has a chip. This one has a separate chip. So this one might have a separate shunt amplifier chip. It's buying a gift for the you in the future. That's right. I was into this. What the hell is this? A hat that says "Fish fear me"? Did I think I would wear this? It's like your own personal Santa Claus. So, I don't know. Oh, I can measure my power grid with this. Don't hook this piece of shitty plastic up to anything that looks like this. I don't think most people will have trouble with that, but just to make it clear, no, that shouldn't be there. Yeah, no diagram. Oh, here's the diagram. Okay, so again, negative side. God damn it. I didn't know this would be a thing. Our power supply is not isolated. The grounds are not isolated within the modules because the modules all have inside of them all of the grounds connected together, right? All the grounds are connected together. So while this one is great for measuring negative current, we suddenly solved the problem that I wasn't having. We solved the problem that I wasn't having. Negative side current measure current display on positive rail. Don't you dare, AI. It sounds like you're asking how a positive supply rail can monitor a negative current while producing a positive. No, that's not what I'm asking. Current sensing on positive and negative voltage rails. Bada bing. Oh my God. Give me all the cookies and stop doxing my work email. Working on a design that uses 2 separate buck regulators to generate a positive and negative voltage. I'm trying to implement current limiting with a current sensor. So this is off scope from what we're doing. Sensor resistors integrated into feedback loop is shown in the block diagram. And then we've got a bunch of stuff here. Not quite our problem. It's adjacent to our problem, but not quite. Measuring current on a negative supply rail. This used to be our problem, but now we have a solution for it. As an AI, I can tell you about current measurement, and as it is unethical and morally wrong. What you'll want to do is boil the baby. I'm an AI. I'm developing a power monitor for a retro computer that will be between the PSU and the logic board to measure the voltage current of the power supply lines. Logic board runs on 3 voltages, 5, 12, -5 or -12. My monitor is based around an Arduino Pro Mini, blah, 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 blah. Measure DC current in the loop. My dog is going woo woo at the door. Like a normal speaking volume. Shunt current measuring on a negative voltage rail. Apparently it's not tricky. Apparently all of them do it. Current sense amplifier circuit also works here. You can place the output load resistor on a positive voltage to get the positive output. Buffered ADC reference. What is that thing? Are they just saying that you can just swap your shunt over to the other side and it's measuring the difference in current between the two, but can it handle the voltage that's there? Because what we're looking at is a voltage on one side and a voltage on the other, and they're both adjacent to 12 volts. When there's a lot of current used, it's going to change just a little bit because that voltage drop across the resistors, V equals IR. And our R is very small, and our potentials are very close to each other, but they are... Well, no, shouldn't that be able to handle it? If I hook it up like the top one, but instead I flip these two up here and I get the direction right, shouldn't it just work? That's what you were getting at. I have to run a show. I have to entertain people that aren't just one person. I have to get to my conclusions naturally. Which one is the 7824? This is just one that has just a brutal voltage range. Input, VPP, unregulated input voltage. Well, that sounds like a government problem. Provide 24 volt. Okay, so it's just a 24 volt 78 series. What does our meter do? What our meter? What our do meter? Amazon.com. Look at the thing that I was looking at. And what's our input voltage? 10p. You can get 10 of these? Why would I do this? Why would I do that to myself? Operating voltage, 4.5 to 30. Okay, let's get a 7805 on this thing. We'll put a 7805 on it. We'll work close. I mean, I could clean off this thing too. I'll do that between streams. I'll blow up this thing and we'll get rid of it because we don't need to do the stress test anymore, although I am concerned about the microcontroller handling the screen. We'll leave this open because I need to start building circuits in here. And actually, when I build the different amplifier stages, I'm going to have to spread everything out. It would be nice, and I was thinking about doing this, Gonad, you'd appreciate this, if I built the whole driver circuit, the whole circuit for this thing on the entire back and just had it hinge outwards so that I could get in there and like mess with stuff. It would be kind of funny to put maybe like these circuit boards here and like just have a couple layers of them come out like that. I don't know. I'm just going to still keep it open like this. I have an LM7833 because I think it's funny. What is that thing? Like a giant sandwich. Like an old radio or something, you know? Have like a service panel. Like in Star Trek. I'm not going to do that. Let's not get too complicated. But I do want to spread out with this thing because there's a lot of like sections to this. So like having a circuit board just be my outputs and have the amplifier chips here with all of the adjustment potentiometers, and then have them, and we're going to have to do chips and sockets. The chips are going to go in sockets because, you know, who knows if I blow something up. Yeah, exactly. It's nice to have access when it all goes wrong in 3 weeks. And then having to separate the different boards out, that's going to be really annoying. It's going to be that's what I've been kind of working out here. I've been staging all the different pieces of this thing and figuring out, you know, how's it going to go together? How many standoffs am I going to do? How many this and that and the other thing? How am I going to hook this up when it breaks? And test individual parts. So more like constantly, have faith. I've done better than that. You guys are right. I hate to say it. I hate to admit it. You guys have experience with some of this kind of stuff. This magic moment. Okay, so I've got a bunch of 7805s. I gotta stretch those legs a little bit. Oh, I do have some sockets. I guess these came with the op amps. I bought a bunch of through-hole op amps on like eBay and Amazon, and some of them just come bundled with sockets. So maybe we'll use these. You know, we've used sockets in the past to hold components. We put like a couple resistors or something on it. I would have 4 available. I could make the 4 resistors that, no, I don't want to do that. That power the op amp circuit, that make the op amp circuit do what it does. These I built for some microphone testing, and I just don't want them to look like this again. This is a little bit much. If I have to replace any components in this thing, like these worked. These are just variable frequency filters. Or no, they're each individual op amp is filtering a specific frequency, and then the gain is adjusted through the potentiometer. So you have gains of different frequencies. It's basically just your EQ circuit. But it went together so sloppily. It's not a very clean little circuit there. So I'm going to, again, spread out. You want to build stuff big. But I guess these sockets are not. Anyway, over here, I've got a whole collection of 7805s. So we'll just grab one. And we're probably going to end up blowing up one of these meters with this little test. This is how you do markings. This is how you do markings. Listen up, all those chip manufacturers that are definitely watching and not on permanent vacation for all of the money that they make. You can read this from space. 7805 P+. I could hold this up to the Atlantic Ocean, and even though he's on the other side of the country, Gonad, the other side of his country on the other side of the ocean, Gonad could read this. I could hold this up, and he'd be able to peer over all of the landmass and the ocean, and he would say, oh, that's a 7805. He has a different accent than I do, but still, he would say something akin to that. Good old National Semiconductor. This is probably as old as I am. Possibly a little bit older. And those markings are still clear. The markings were still seen in spite of the fog. Why is this thing auto-adjusting? I can see the details of the breadboard. I can't see the details of the breadboard. I can see the details of the breadboard. That's just the shadow. Okay, hold on. We need to close the aperture a little bit. Ah, there we go. Beautiful. Are we looking for a 7905 negative? No. So, for testing, I'm going to create the positive and negative power with this power supply. When it comes to making the positive negative 12, this module will create it. And so I have 2 of the modules. One powers the internal stuff, the other powers the module under test. Those are the ones that I'm going to monitor. We need the 7805 because I'm going to try to use one of these panels to measure positive current, and we'll watch it explode. Although it exploded for the guy whose comment we looked at. Where was that one? I don't think it was this listing. Oh yeah, here we go. This one. This destroys the meter. Yellow and red, thick red to positive, negative to negative, black wire to negative. This is the way it's supposed to be measured. And then this is our alternative. With the 70, with the regulator here, making sure that it doesn't get the original 12. That's how those meters measure current. Those meters are normal direction current meter. Common ones wanted to measure the current on the radio in my car. It tells you not to shape the ground between measurement, voltage, and load. Not to share the ground between measurement, voltage, and load. I don't have a way to do that. Yeah, I don't have a way to isolate the ground. Unless I power it with 24 volts from the positive and negative rails, which, can it do that? I think it can do that. Working voltage 4 to 30 volts. I don't know if that's what the input voltage is. Need 2 separate power supplies. We have 2 separate power supplies, but they would be connected by ground. They're going to be connected by ground no matter what. Unless I fully isolate it out, but I don't really know. I don't quite know how it. I mean, ground isolation is a weird thing. If you want a digital and analog ground isolation, you just run one trace between them. But like, voltage levels are voltage levels. This is very confusing to me. This is supposed to be connected on the negative side, but current flow is current flow. Connecting this to the same as the sense pin blows it up. How much current am I measuring? Small amounts, actually. If these things are supposed to be multiple big amps, that's not what we're doing. I mean, like modular synthesizer. Hold on, this is going to dox emails in just a second here. Yep, there they are. Boop. Go. What's the general feeling out there regarding the current state of modular? That's not what I asked. Current rating. Don't dox me. And where's the pop-up? Where's the pop-up? I hate this redesign. Thinking about experiencing blah, 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 DIY, CV input, 100 kilo ohm. I want like the whole module. It's not much. It's under an amp. And we can look up other power modules. Your rack voltages are positive 12 volts, negative 12 volts, and 5 volts. Different modules may use 1, 2, or all 3 to varying degrees, which is a troubleshooting thing. We can know more about what's going on in a broken module if we can see all 3 of those currents, which I can do on my Agilent power supply. Not at once, but it would be nice to have 3 individual current monitors on this device. More power, they are talking about 12 volts, 12 volt circuit. Speed coming down the pipes, blah, blah, blah. Okay, so they're talking about that stuff. The specs on the IntelliGel 7U page, you can see the numbers. All right, let's take a look. IntelliBlah. 7U performance case. Okay, so this is like a high performance case that uses just, look at this. They just use a sealed plus minus 12 volt module that they place down on their circuit board. $600. Limited time blemish sale. Oh, $659. Okay, anyway, what are the specs on this thing? 284 HP, blah, 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 3 amps. So 3 amps of, oh yeah, 3 amps at minus 12, 3 amps at plus 12, and 1.5 at 5. Those are the specs. Which, by the way, I went to Pololu and may have spent $20 on each module that takes plus minus 15 volts DC and creates both positive 12 volts at several amps, more than 5, positive 5 volts at 3 amps, I believe, and the negative one I actually got from eBay, and that one does like an amp of negative 12 volts, which nothing is really using that much negative 12 volts. This one does 5 amps of it, or 3 amps of it, which is pretty excessive. I think I could get away with like 1.5 amp, and that's enough to power an entire suitcase-sized Euro rack. Analog meter would be so much easier and nicer to debug. I'm starting to come around on that, to be honest. Just have an analog meter that you kind of know is doing something. The problem is the ones that have that one marking so close. Panel mount ammeter. And it would just go in line with whatever it's measuring, which is nice. These would be the other alternative, but this thing is $15. That's so expensive. It just has the little probe current. So yeah, you would just supply it, and then you would also have your probe. This one's on the negative side of the load. AC 80 to 300 volts. Jesus. Voltage and current can be displayed with different color LED. It's too many features. It's like a lot of this stuff is there for like electric cars. I'm doing it for diagnostics of like toys. 0 to 1 amp analog meter. They're two, look, see, this starts at 1 amp. It's like 1 amp is right there. I want a little bit more precision than that. I mean, this will basically just tell me if something's shorted out. It'll just fly up to 5. But wiggling needle is easier than blurred digits. I like the blurred digits. The blurst digits. This one does it all. AC, AC voltage, DC current, DC voltage. And they even show DC current on the positive side, although I probably could connect it to the negative voltage side as well. Yeah, I need a smaller range. It may exist. Look at this, they're showing better meters. These are like $15 ones. There's expensive ones. Well, here's a couple different ones. This one does 1 amp. 1 amp actually might be the range that I want. Because if a module's drawing over 1 amp, 2 amps would probably be the better one. Because they really, each individual module should not be drawing over 1 amp. And I remember I'm connecting one module. Connect it backwards, it'll just push the meter the other way. I didn't want to go analog with it. I didn't want to. You guys pushed me. Are those lamp leads or are those mounts? How does this mount? Yeah, maybe I do that. Is there like a 2 amp one? No. 20 amp. So it's 1 amp or nothing. Yeah, the 2 nuts and screws, and I think they also double as the... Well, is there a backlight? I don't know. These might not have backlight. I don't think these have backlight. Yeah, 2 M2 screw terminals. Be here and here. Do those go to a lamp? No. All right, let's see what people are saying. Meter works within specifications. After comparing it to the reading with a multimeter, I can confirm this meter measures current fairly accurately. That's not like, it's not a lot of info, but I guess it's okay. 2.5? No, that's not the current rating. I don't like these because they feel cheap to me as somebody who grew up in the early 90s circuit building stuff. Bottom ones are mounting only. Rather than the guy who was like, these suck so bad. That's for the digital one, yeah. Nice 3D printed covers. I mean, we'll just make a panel for them. Let me just open this up in a different window. 1 amp might be a little bit too close to what we see overall, though. Like 1 amp is, I guess 1 amp is concerning out of a device, but I think some might draw that much. Maybe not. Maybe not. I think what would be a power hungry module? Like the analog stuff that I build are is going to be pretty crunchy in terms of how much it eats. $120 milliamps, 100 milliamps, 100 milliamps. Besides Metasonics. Hey, that sounds like something from Undertale. Sans Undertale. Among Us. I know man, Among Us memes. Those have gotten old, huh? 200 milliamps, oscillator gonna be blah, blah, blah. I saw a Metasonic special case with 8.5 amps in it. What the hell? Digital modules tend to be a bit more power. Ones with tubes in it. I don't know how many tube modules there are, but those would require quite a bit of power. Some modules are hungry for 5 volts. Stiltson Hammer draws it. Please put a number behind that. 680 milliamps is like a legendary amount of power. So I think one amp is probably going to be right, because if something gets up to 1 amp, good old 3 amp filament wire. Ugh. Well, I don't have the option of 1.5. I don't have. It goes from 1 amp to like 20. Well, no, it goes 1 amp to 5 amps. So I think 5 amps is out. If it gets to that, I'll have to use my own power supply to measure. 130, 200, 120. The yellow ones. Wave player, 150 milliamps. Okay, so unless we get way into the weeds with this, we shouldn't be seeing over 100. So I think 1 amp. Yeah, if we're only plugging one module to observe, and my only problem is this isn't going to give me like good numbers. I don't think the other ones would give me good numbers anyway. And we don't get the voltage monitoring to see if something is shunting. That's the one thing I don't get out of this. If I see the needle fly way past 1 amp, that just means that I need to take a look at what's heating up on the module, right? If we were to draw more than 1 amp of current, couldn't we use a current limiting resistor calculated carefully? Yeah, I mean, you can do, there's a bunch of different, you can do stuff with MOSFETs that will like stop current from flowing if it gets to be too much, and like, you know, shunt out and fuse things. I don't need that. The power supplies that I have, by the way, only handle 250 milliamps. I just realized. These are 250 milliamps. That's at 12 volts, but still. But then can I resurrect the ammeters that I have? Is it possible to measure high side with one of these low side? Probably just a matter of the voltage damaging stuff. So it's like if it can tolerate that. Is this going to be all talking? 3-wire, 2-wire. He's talking the whole time, probably saying good stuff, but I can't sit here and watch a YouTube video right now. I have to jump through. This is a slightly different one. Current project panel meters taking longer than expected. I don't know what that's like. That's the most relatable thing he's talking about. I decided to put up a video of my expertise with these cheap eBay panel meters, in particular with how to power them safely and how to use them to measure voltage and current in the power supply that is a positive and negative rail. Aha! This is exactly the video that I need. I just wish I knew what he was saying. I don't know what he's saying in this video. I almost peed myself. Oh, wow, that's getting a little excited. So, let's see. What are the conclusions here? That's going across the load. You've got a Zener diode voltage limiter in that thing. And here we have positive ground and negative rail. And somehow this is properly measuring the current on your positive and negative thing. This is similar to the diagram that we were seeing before. The negative voltage, or the negative current rather, is being read. But in this case, but these are the 2-wire ones, not the 3. You don't have that ground wire, I guess. The yellow wire, and then the ground wire, not the positive wire, and you have some kind of a diode in there. Are these, maybe these are being powered on their own thing. I may have to watch this video in order to figure out what's going on here. So to get down to the data sheet, I guess, and figure out how this thing goes about its business. Because it's, yeah, positive 5 to 15 volts. And then, what is this diagram? What is that thing? I don't know what this is. Is this an op-amp circuit? Is that what's going on? Are we looking at op-amp circuits? Well, the HW cave has knowledge that I don't, and I'm going to need to yeah, is that a shunt amp? Current shunt resistor, form a metal bar. Oh, this is a different one than what we have. Okay, so this one comes with an op amp and a shunt amplifier. This one's a little bit different than what we have. Yeah, so that one has that amplifier. Ours aren't that high current. It's got kind of a different micro and a different layout, and it doesn't have an extra amplifier. It's got just the shunt. I don't think there's anything internal into there, but that doesn't really change our diagram though, because that's an internal thing. So this piece right here is internal to the circuit. So on his diagram, final diagram, well, it doesn't make any sense. And then the Zener diode, I guess, it's one way to power it. I could do the 7805 for both of them, or for all of them, rather. I just don't get his diagram. I don't get what's going on back here. There's a shunt across this piece right here. So nicer MCUs come with an op amp that's directly into the... This thing was $6. I don't think anything that fancy is in here. I think maybe it's just that when you get up to those high currents, the voltage differential across this thing isn't too much to blow this up. And so they put it through just like a voltage divider or something. They put it through something. I'm not going to say voltage divider, but they do put it through some... I think this can tolerate it, but I don't think it has an amplifier in it of any kind. I think it's just analog sensing on multiple pins and then comparing them. Maybe not. Maybe I'm wrong. So panel meters taking longer to describe voltage current, blah, 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 blah. This part of the diagram is baffling to me. I don't know what that is. I guess maybe that's the power supply, supplying the positive and negative. That's maybe what that is, with a capacitor across the different levels. But then he's taking a Zener in order to power the unit, and then the negative is connected down there. So if I use not a Zener, but wait, where is that power coming from? Where's the positive and negative on that diode? If we're just shunting the diode down to the rail, wouldn't you then be measuring the amount of current that goes through the loop to ground? Voltage and current on positive rail. That's, I guess, okay. So really that brings us back to here. That means that this circuit that I had on the whiteboard was valid. That right here. This apparently does measure the positive load, even though everybody shares grounds. He had two isolated power supplies. Yeah, wait a minute. I don't have that. We're more like the whiteboard diagram. Yeah, those are, well, they're isolated, but they're also connected together over here. What? So whatever's happening on the negative rail has a path back. Whatever's happening on the positive rail has to go through here in order to get back. That's how it's measuring the current. So that won't work for us, because in the modular synthesizer stuff, everything is just connected together. All the grounds are just always connected. So this won't work. Even if I isolate all of the ground, that will then have to go through all of the ground. And the reason that I'm saying this is because if you look here, like the M303 power input, let me just get the circuit board for that. As an example, the M3, well, actually the M303 is a dog shit example because the power plug is terrible. Do I have any other like real modules in here? I have the one that I made, and this is pretty common for these modules, is that you have all of your grounds on this plug. They're all connected to each other. So if I were to try to measure using the method that we saw over there, we would not really be seeing an isolated supply path. Well, actually we would. Wait a minute. If I do it this way, if I have a different positive and negative power supply, which I don't have in these. I don't have that in these. These share. Although, if I use both of these and only one of the positive rails and one of the negative rails, that would technically isolate it out. That's crazy talk. Hold on a second. No, I don't think it can work that way. If I did, let's just grab a little corner of this thing and talk about it. If I did two supplies, and then those had plus 12, G minus 12, plus 12, G minus 12. And I took minus 12, and then I did the amplifier here. And then I have plus 12 going out. And then I have an amplifier here, or sorry, an ammeter. And then this was also connected to this ground. And then my second supply would be between, this would be all the internal voltages that I use. That way, if this uses minus 12, it's still going to find its way back on this ground. If a module that I plug in uses plus 12, it's going to find its way back to this ground. and then go through the ammeter. If that doesn't really isolate it, does it? That's very strange. Would that work? I know my my diagram is a little strange. Voltage potential between ground and there, and then this, would that influence it? Technically, that's the first potential. I mean, I guess I could test this. We could test this. I need to hook this thing up to DC in order to get that tested, but that's something that we could do. Those two would just talk to each other. I don't know if that really works. So the way I'm isolating the two power supplies is by splitting the grounds of them. And so the grounds aren't, well, maybe having that, no, that ground path should be fine. Because then it shouldn't influence the meter. The meter's coming back from the module under testing. I guess there's only one way to find out. How do I power the two different things, though? I'm going to have like a 7805 here. Have a little sneaky 7805, hard to read. Go there, and then go there. And then yellow wire. And then, I don't know how that one does it. Yellow wire goes to there. On which lead? The one that goes all the way back to... But then that's, wait a minute, but that's positive. And I'm referencing it at ground. I don't know if that works. There's much potential for us to blow this stuff up. What does it look like on the whiteboard one? Yeah, they're doing what, okay, that's what I assumed. But they have a separate 7805. 7824 and a 7805. Why 24 volts? I mean, yeah, they're dealing with positive and negative 25, or sorry, 35. So 1.2 to 30 volts, 7824 going into that one, and 7805 going into the other one. Negative 1.2 to negative 30. That ground wire still goes down to ground. Positive 24 and 5 volts. Well, 5 volts off of the rail? In is common in this case, so what is that accomplishing? That's making our positive voltage? Yeah, giving it 35 volts is close to its limit. And you're asking it to regulate that from negative to positive, so that would be, yeah, 35 volt potential. And so you've got 35 volts coming in here, and then it's outputting the 5. So I guess in references, we're dealing in references. So we've got, why is that a 24 though? Why would we be giving 24 volts out to this when we're giving 5 volts to the, maybe the negative load doesn't draw as much. There's some specifics to the application that this person is doing, I guess. But I wonder if we need 2 separate supplies, one for each. And I don't know if this really functions properly, but we'll test it. I can use 2. I have plenty of 7805s. And then this one, instead of coming off of positive 12, because then it would be seeing a 24 volt differential, this one would be coming off of, why wouldn't it? I guess it would be going from ground to unmetered ground on which circuit? Would it be this one down here? Going back to that one, if it's also using -12 over here, it would have to be like over there. And this is internal stuff. Maybe we use the internal -12 and reference it from the positive, from our regular ground. So it'd be like that. And then this one. Oh my God. This is going to be a hell to wire up, but let's just get started and we'll figure out exactly the minutia of the diagram from there. So we're looking to put a positive and -12 volt current meter together. I guess I'm going to use the ones in the panel. We'll put this one aside. And these leads probably will plug into here. Yeah, that's a pretty good fit, actually. It didn't ruin the lead. They're soldered on the ends, so I might get away with poking them in. There's a 1 amp limit to the breadboards. And then I've got these things. These look like they bridge the gap, but those pins are a little bit big. Oh no, that's pretty good. Luckily they used 0.1 inch spacing. They were merciful. So on the DC side, I'll put on top. We'll just see if we blow stuff up, huh? Back to the world of breadboarding. Trying to make sure I don't blow everything up. I don't even know where those pins are. There they are. Okay, now we know where they are. So I guess I'll just connect those to positive and negative on the rails. So let's move these all the way over to the side. So we don't blow anything up on this thing. I'm a little bit off there. We'll go right there. Pick this up a little bit. See what I'm doing? So ground and VN, that's the DC side. Those will be shared. I'll just steal jumpers from the other board with tweezers. With the power of tweezers. Have you tried the program Atanua? It's about making these things but working. It'd be easier to read and draw. Interesting. Atanua? I've never heard of it. Altoona? I know there's a there's that one thing, like the HTML, where you put together the things with current flows and stuff, but I don't know if this really falls under that sort of thing. I don't know if that really is what we really need here. I just needed to kind of suss out a little bit of the design on myself. Miguel Oz! Oh my goodness, how many months are on that one? 53 months from Miguel Oz. Miguel Oz, thank you. Thank you, thank you. Appreciate all that. That does help me out. You guys just continue your subs. It's always nice to see. It's so humbling. Yeah. I've been really struggling these past couple weeks to kind of keep things going. I gotta power through and get motivated again to continue on, because these projects need to see a little bit more result. But then we run into something like this where, oh look, you know, positive and negative voltage rail current measurement is apparently a lot more difficult than I thought it was. I thought you'd just throw a shunt amplifier on it, but you know, Pseudomaze and some of the other people in chat have appropriately pointed out that when you have a bunch of volts, your device still needs to tolerate that bunch of volts, even though it's just measuring a differential between them, a slight differential between them. And that's where we run into problems, is that plus 12 volts versus the cheapest thing you can possibly build to measure current don't really see eye to eye. Or let's put a space in here, one pin space. Jeez, afraid I'm gonna break something. Hopefully these are making contact inside of the thing and not just like pushing up against the square holes. Jeez. This will be my DC 15 volt. Oh no, there's not sufficient disk space to continue recording. Oh my God. I forgot to clean out the drives. Hold on. We have to take it aside. Put that away. Weird porno drive. I mean recording drive. Everything but today. Oh no, it's a full list. This is many, many gigs. Let's just take the smaller one. 700 kilobytes. That's not, let's take a slightly larger one. So I'll just take like, what date's today? 21. So we'll do like the 13th. Oh, that one's huge, 12 gigs. Cut that, and then let's put that into the recording drive. Details. What's up, Brink GG? I had a hard drive fill. Best way to do this is you do one really quickly, and then that frees up the disk space, and you can start your recording again, and then I can transfer the rest in the background, so there'll be occasional little visual bugs. I do this just so that I have all of my stuff on a drive, you know? I don't know what it is about the Discord lately, but my Discord has been doing nothing but like recommending stuff for me to buy. I don't know why they're like this suddenly. They're like, bother, check out this awesome hard drive controller that's obsolete, and this audio thing that's obsolete. Bother, look at this. Bother, look at this. Bother, look at this to buy. Like, I'm not buying anything. I really have to not buy anything. Transferring stuff through drives and just, God. Buy this eBay submarine. Yeah, it's made out of carbon fiber. I'm sure you have a better controller. Like, it's like, stop. I'm not in the habit of just buying stuff. I'm using all the stuff that I have. I'm probably going to have to buy a new hard drive soon. Like a new 4 terabyte or 6 terabyte. I just returned a motherboard on eBay because I didn't need another project. That's the thing, is like, I just can't keep scoping it like this. I don't have the money. Buy this light, buy this camera. Look at this camera, it's cheap. No, I'm not looking at that. All right, there's the one transferred. That was actually pretty quick. I got a debate about whether or not I should buy like a big hard drive, because if I buy a huge hard drive, I can put it in the file server and slowly upgrade the file server to have more space. Although I just did that with 6 terabyte drives, it wasn't cheap. So maybe I should just buy another 4, and then by the time this 4 fills up, how's this one doing? Oh yeah, there's plenty of room in it. Oh yeah. Yeah, so maybe not buy another giant drive and just fill up another small one. I keep all of my old streams, and there's something to be said for not doing that. You know, maybe I shouldn't keep every single old stream, but I've got the ones dating all the way back to when it was just me and a couple people that I knew through Discord. Actually, through IRC, to be honest. That's the wrong one. Stream storage. And in here, paste. 8x 6 terabyte drives of 10 to 14 terabyte. Yeah, people who like hoard the data are crazy people. They're crazy people. I don't have space like that. I have 3 6 terabyte drives in a NAS running RAID 0 or RAID Z or whatever. And they've been working for me for many, many years. And I just swapped them all out with 6 terabytes. I don't even do VODs now. Damn. How do you just raw dog in life? Like, what is that? No, I have the VODs. They bring in some people. You know, we've seen some people chatting from I was about to say eBay, chatting from YouTube. Purchase a meter. Let's do it, and then let's see what happens and deal with it. No. We're gonna build the thing. Yeah, with the music stripped there, strange. It is very annoying to watch VODs where the music's been stripped. I've watched a couple larger content creators in the recent past. It hasn't been lately, but in the recent past, and it's like they have some kind of a condition, because they'll just start bleeding out of tune, off tempo pieces of songs. You'll be watching them just walk by, and they'll be just like, I don't want to wait for our lives, and then it continues on. You're like, ow. Like, why did you do that? All right, so these are on the same DC power supply down here. Now we get to the more complicated stuff up here. What I'm doing is I'm using the positive and ground of one supply to measure the positive current, and then the other one is using the negative and the ground supply to measure its current. So we're actually measuring it on the negative rail. We're measuring it on the ground rail of only the one that's associated with the positive rail. And then the remainder shares, I guess the internal stuff shares this stuff, but it's not on the metered line. It's after the metered line. Does that make any sense? I don't know if that makes sense. I don't know if that makes sense in terms of isolating it out. We did kind of the clever dick way of doing this, because these only measure negative. So we are measuring this loop, and then this one is measuring this loop. To this connection. This is a very confusing diagram. Basically what I'm doing is I'm taking positive and ground and I'm measuring them here. And then I'm taking, I guess, negative 12 and ground, and I'm measuring them here. But we're measuring this rail, we're measuring this rail. Our return is going this way. Its return is going this way. But if I use negative 12 here, that goes back through on its own. It doesn't go through the meter. And the grounds connect here. But couldn't plus 12 make its way through the other ground? I don't know. That's why we're putting it together. It's confusing. There might be a better way to draw it too. So that would mean, all right, let's get some load resistors here. If we're doing 12 volts, oh, I need another 7805 too. How am I internally powering these things? Wait a second. Can I do it with one 7805? Or do they need to be completely isolated? We can have a poll? Maybe. No, I need two 7805s. I don't know why they're using a 2.4, but I'm going to use a 7805 in both locations as per this diagram. So we power one from 35 volt to, well, not 30. One from 12 volts to ground, and the other one from ground to negative 12. I probably have a negative 7805 in here, but we'll just do it this way. We'll see if this works. We'll do it this way. Oh, what a crazy thing. How am I going to measure 5 volts then, if it also shares the ground with everybody else? I want to try this just to see if it works now, and maybe I'll just buy those other ammeters. Fuck. That means I don't get to measure 5 volts to see whether or not it's 5 volts. But it's like the 5 volts that goes to the module is it's using that same ground. They all share ground. So if I measure, that doesn't work. It just doesn't work. Son of a bitch. I need to find an ammeter that measures the positive side. 7805. All right, so these are both 7805s. Get that one in. Where's the other one? My 7805 is that large. There it is. What's up, Gamer Pino? This little pokey. No, it'll be 5.04. Well, these can take a range. They've got their own regulator in them. They can probably just take the 12 volts we give them. I don't know why the 7805s are in there. I think they're in there because this circuit specifically is 35 volts. So maybe we don't need these. We don't need these. Lest they just be in there for isolation, which is not that necessary. Hold on a minute. Double check the voltage. These guys. 4 to 30 volts. So we could just give it the voltage. But the question is whether it'll blow up and release a whole bunch of smoke. What are these? What's your circuit? These have little things to clip in or put a wire through. But they're also $20 each. Jeez. I didn't know this would be so complicated, you know? Yeah, so this is essentially very similar to the other diagram, except that the other diagram doesn't isolate that common. This is essentially the other diagram. Wait a minute. Oh yeah, but somehow they isolate the load out here. That's why. They're isolating the load before it gets there, and we can't do that because when you plug into a module, they share that the common center. That doesn't work out for us. So essentially what I can do here is use the positive and negative 12 volts of the two supplies and hopefully get an isolated thing going, and then we can hit it with like a bunch of loads. Now, I have big resistors. I have them around here somewhere. They're a couple of ohms. We got to calculate and see that they are the appropriate load in this manner. Let me see where they are first. They're in one of these drawers. I never do anything with them, so they may have been cleaned up. I don't know. Not in that one. That's all switches. Yeah, they got little AC. They're not really clamps, but yeah, they're just coils that the current goes through and then induces a tiny little voltage. A tiny little voltage. One's in there. Oh yeah, here they are. All right, so how many ohms do we have? My big old ceramic ones. They do make tiny current transformers. Like you could use as like a component to measure current across like a line and then into a shunt amplifier, but I don't want to make microcontroller stuff. These are 7 ohms. I don't know what wattage that is. So V equals IR. How much current are we talking about? Really, we want like probably 12 ohms, but what would it be? It would be V equals I over R. So if you, which direction is that? Is it 12 over? That's not right, is it? 7? That's 1.7 amp. So I guess we could do that. It's going to create a lot of heat, but we could make a 1.7 amp load on the end there using these high current resistors. That one's broken. These have been sitting in this drawer for God knows how long. They're very old. They need AC. Doesn't it? Aren't they inducing? Hold on. Volt amp meter, DC 5 to 1,000, 100 amp, waterproof, dual display. Current voltmeter, mini ammeter gauge with. I don't think it's AC. Power and load. It's just by the current in there. There's going to be a magnetic field around it, and you can, I guess, induce something. It's probably sending like, you know, wibbling signals into that. Oh, those transformers you're talking about. Man, oh man, this is weird. So what I'm doing is I'm setting up our load. So that's what's going to sit over here. Oops. Best resistor drawing ever. All I need to do now is make this circuit, although the 7805 is not going to be in there. So that part disappears for the sake of simplicity. Maybe I should redraw this whole thing. And then how are the amps being, I mean, the circuit that we saw put some kind of a diode here, like a Zener of some kind, and he had it going to the negative supply. But that was on a different meter. So if I don't connect the ground wire and connect the red wire here, and I have something that limits it, or if it can just get to -12 in reference to this, or I run it off of the other power supply. Oh, this is so confusing. So technically this would be going up to the positive rail and this would be going up to the common rail, because that's what it's in reference to. We don't have a 35 volt difference between these to blow the thing up. We have 12 volts, which is within its specifications. So we would not have this. Instead, this would go to here, which this looks a lot like the diagram that the guy said would break the meter. Although they could have been using a different voltage. And then this one would go to the common rail. Where on the common rail? It would be after the meter. Oh, but we're not measuring there. This one would go after the, oh, but this one doesn't even go to that either. Okay, so this would just go to there. That would be the diagram without the 7805s. Should we see what we're going to break? Let's see what we break. That's black wire, that's red wire. This one is the red wire. Black wire. We predict whether it smokes. Let me get it hooked up first. Double check. See, they also have the black wire going to the common. This one goes to the negative rail. They do both of those. They do all three of the wires connected. So maybe we do that too. Like that, and then this one would also go to common. Would be just like over here. Because then that sees a difference of 12 volts. This one sees a difference of 12 volts. And ground is over positive, so I don't know. I don't know if this will work, but I guess that's the plan. I could redraw this and it would look a lot more clear. But we've got a red, black, and a yellow wire that exit. Then we have a shunt black and red that we're going to connect to whatever it is we're doing. So let's put together our shunt, or sorry, our load. So let me just clip some of these off, some of the wires here, and we'll solder them together. Now this is going to draw 1.5 amps at 12 volts. So I'll want to probably not, well, I'm going to have to hook it up to the breadboard anyway. I'll have to hook it up to the breadboard anyway, so I'm going to have to make this breadboard compatible. This thing's going to get kind of toasty, but we'll try to keep it from burning down the house. Do 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 do. Ooh, baby. Burning down the house. I could do wires, or, well, let's just keep this kind of bush league. I do have to solder this, though. So hopefully you guys gained a little bit of insight into how I go about figuring out what the problems are and coming up with solutions for them. But it's just very confusing because I thought we'd be measuring the high side. What's up, Poopsie Doodle? And the problem is we've got like a high side and a low side. And actually, the way these are configured, the way these amplifiers work, they're perfect for the low side. I would need something in the exact same package, and I need two of them in order to measure the high side. Because apparently this wants to measure the minus line, and I didn't anticipate that. With all these shared power supplies, in order to measure 5 volts, it's all using the same ground. So what do I do? Well, we were able to isolate negative 12, but in the end, I don't really think this is going to work. I'm going to need to find something that will also measure the positive line for amps. They self-limit by desoldering. I don't know if they're gonna do that. We are going to be running 1.5 amps, and since prototyping board is only rated to 1 amp, we're going to be in kind of a bit of a situation there. I could use jumpers that need to be soldered. Let's get all these jumpers out of the way over here. The junk on the desk is starting to get to me. I'm going to have a mental breakdown soon. Let's get a couple wires that match up. I'll just solder them. I don't want to draw this out too much. Enough length so that I can make sure that this thing plugs in comfortably. Okay, and then do 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 do. That song is stuck in my head, burning down the house. Fight fire with fire. Doing a right angle like this means I just need a big blob of solder. Shit. There we go. Haphazardly held together, just the way we want it. This is a temporary test setup, so whatever. Because I don't even know where I'm going to have to go from here. We're kind of barking up a dead end. How is this so complicated, you know? I just thought I'd be able to stick an ammeter on the line. That's what you do with the multimeter. The multimeter has much higher voltage tolerances. Don't want to get if I hum it a little bit too accurately. I love the synth solo. Okay, this is a lot, chat. This is a lot. That's our load. And so our load on the plus 12 goes to the yellow and red of our plus 12. And the other red as well. All the yellows and reds. So plus 12, yellow, red, I'll have to make a couple jumps, actually. GPMG wants all of your money. We want your soul, your passion, your clothes. I have to do this because I need more than what's here. I need more holes, which is what the record execs tell you. Okay. Oh my god, there's so many connections. 1, 2, 3, 4, 5. Okay. All right, I think we can do it with this. Oh, wait, but I also have to jump these all the way back here. So we'll do that one too. So we're taking... That's not going to reach. Where are my super longoids? Actually, we can probably move this closer. Let's move it a little closer and maybe use both sides. Maybe just use both sides and move it in a little bit. We don't need to be super compact with this. Right there. Put this one here. This one here. Now we're nice and spread out. Everybody's all over the place. So I need jumpers to go from ground to ground to ground to input. Plus 12 is only going out to plus 12, so we'll leave that one alone. That would be, let's say this one is going to internal stuff. No load on that one. Ground here goes to a bunch of stuff in one of the amps. Where's that pin? Right there. That's going to a bunch of stuff. And then that goes to, on the positive side, both of the black wires on this one. What are the black boxes on the breadboard? They're plus minus 12 power supplies. They create 250 milliamps of plus minus 12 when given 9 to 30 some odd volts DC. And the problem is these aren't going to want to stay plugged in. Damn. Well, I could solder a single pin to them and then jumper them over to everything else. This is where spare pin header comes in handy. Three, six pins. 6 pins. 6 pins. This is just a temporary test. I mean, everything's going to be kind of all over the place. But what if you can put them in parallel to double the current? O-ring power supplies can be kind of tricky. It depends how smart the power supply is. And unfortunately, with regulated power supplies and like switching power supplies and stuff like that, you can run into a problem where if the voltage runs on one power supply, the other one runs with it, and it can get messy. So you've really got to check those data sheets to see whether or not you can parallel your power supplies. And then when you look up O-ring power supplies, you just find a bunch of rubber rings. I don't know how people are combining power supplies with those, but apparently that's all you get. It has been a very relevant search for a long time, so. This just makes sure that I get all my connections in here. Because I think this is doomed. I think I need to find a high side ammeter. I think that's the only way that I'm going to be able to do it. But the nature of the beast is that everything wants you to measure it on the low side. None of the grounds are isolated on Eurorack stuff. It's all one ground. this guy over here. That was weird because the current shunt that I got for the computer power supply that I built, the one that creates all that 12 volts, that was a positive power shunt. So you'd put the resistor across your positive lead and it would measure everything that's coming back. That's why I was under the impression that these would work the same way. So on our -12, it looks like I don't need anything but this red wire from here, -12. On ground, I have the red wire from the positive amplifier. That also goes to the second power supply over here. Why is the black wire on that one? Hold on a second. Which one is, this one would be the positive, this one would be the second one. And then this goes, so from here, we go over to this one. Wait, on which line is that? I gotta keep all this straight or else everything's gonna blow up in my face. That goes here as well. And then the yellow wire from this one goes to, oh my god, this is getting crazy, goes to that same ground. No, wait, that's the wrong one. It's the yellow one from here. All right, we're taking this one at a time. Hold on a second. We got to do one at a time. One at a time. One meter at a time, fully hooked up. 1 meter at a time, fully hooked up using my mad, crazy, go nuts power supply diagram over here. I got to make sure I do this one at a time and I concentrate on each of the ammeters and get them all fully hooked up. So let's do this. I'm going to use my crazy diagram. You guys will just get me babbling about weird shit. So we're starting off with the positive 12 rail. The positive 12 rail, which is going to be from over here, goes to the shunt positive, sorry, the load resistor positive, the positive amplifier yellow wire, the positive amplifier red wire, so let's get a 1 jumper in there, a 1 unit jumper, unless I can't find one. Can't find one. Guess we'll just go to the same place, the similar wire. And that's everything on that one, so I don't need this jumper. So that is the positive plus line for that. Ground wire from the same amplifier that we just hooked up. So we're going to the next input. I'll try to find a, nah, I can't find, I can't color code everything. Negative, or rather ground, goes to our internal ground. It goes to the 2 black wires from that first one. So I need a much larger jumper. I don't know which ones of these is actually the pin. So that goes to this wire here. And then that also goes to this wire here, this big boy. And then the red lead goes to ground of the load. So that's here. Put that over here. That's not holding onto it very tight, but something. Okay. The next positive 12 is not doing anything in the circuit because that actually runs to our internal unmetered positive 12. It's isolated, but it also goes over here. So that's not there. Ground. Red, yellow, and ground. So this ground here goes to these two pins and ground. Does it go? It goes ground of everybody. With the red wire? Yes. So actually we'll go over here. So that goes red, yellow, and then bring this one here, and I need that one position jumper. I've got some sitting over here. It's red and yellow and ground, and then -12 goes to the two black wires of this that are remaining. So those two, and then I need this one. Why are they all white wires? That. And now the remaining red wire goes to the see, this is why we plan out the circuit diagram. Helps me get everything connected properly. So now I punch 15 volts into this thing and see whether or not everything explodes, especially given that we've got some floating leads. What do we have floating? Basically just -12 here. This one and this one are floating right now. Yeah, right. This is my first time into the poll. Poll. Is it exclamation? No, it's slash for Twitch commands, right? That's not it. Yeah, I did that. It didn't do. Maybe from my mod thing. Hold on, let's try that. There we go. I had to do it from my moderator view. Nothing came up. Going to add, do you know how to do a poll? It's not working for me. CUI Incorporated is who makes these. Oh wait, I didn't hit enter yet. Hold on. There we go. We'll see like 2 minutes. I'm gonna go use the bathroom and get a glass of water. So we'll do 2 minutes on the poll. Let me start the poll, and then we'll hook power up, and we'll see what happens. Let's go. All right, I'll put on some tunes, and I'll be right back. Where was that? Where's the one that I was listening to? The one that I was listening to like went away. It's gone. I guess we'll just go with the one that was next in line. All right, hold on. I left it pretty open-ended. Like, if it burns out, that's fine. That's also a yes. But not a lot of confidence, huh? I know this mix ended up being perfect. All right, bump, bump, bump. Okay, I gotta work on visuals for polls. I need it to like come up on the screen and like be funny. But I guess the poll's in, right? That's done. You missed it. It was only 6 votes. Show you how popular I am. Look at all my viewers. We had a big boon in viewers for COVID, but I gotta figure out how to get people back in. I think maybe doing edited YouTube videos can work, and also perhaps you know, getting out there a little bit more. I don't know. I gotta find something. I don't have the energy to do what a lot of people do. And I don't know, maybe we'll never be a big show. We'll probably never be a big show. And we can just get comfortable in our britches here. But we can get Burn the Subs running again too. That's usually got a pretty good boon. It got crazy in here during those COVID days. It was pretty awesome. Even pre-COVID, because it was, when did I partner? It was just before COVID. It was actually a little bit before COVID. A little bit before COVID. But it was mad to see all the people who wanted to just like, I want to just hang out with somebody who's working on projects, and since I'm working at home, I got nothing better to do. And so we saw a pretty nice little bump in viewership over that period of time. Get all these screws out of the way. It wasn't huge, but it was consistent. At least for me. Yeah, those were, when I uploaded those, I just recently uploaded those, and it was like, I would do a little bit of a project and then burn the subs. And then I would do like a tiny, I'd start to get my thoughts together and then burn the subs. And then I'd sit back down and burn the subs again. Listen, that's an embarrassment of riches is what that is. That's a lot of Rich Evanses. Oh yeah, so for the adapter collar, should I be using aluminum or stainless steel? I have tubes that are both in aluminum and stainless steel. So is aluminum bad to use in like a crushing application? Does anybody who knows motors know that kind of thing? Like, this would be easier to work with, but I do have a stainless steel tube that fits the bill. Because what I'll do is just carefully cut it, like to length, and then very carefully slot the top of it using the Dremel. Unfortunately, I have to use the Dremel. I mean, maybe I could use a milling machine, actually. If I could use a milling machine to do that, that would be kind of fun. Maybe if I blow everything up right now, we'll work on that. If I absolutely destroy everything that I know and love. Getting sick of this. All right, so let's see here. So positive is what lead? That's this lead for positive. That's going to be, I'm going to juice this up to 15 volts. And this one is, no, that one's negative lead. This one's the 0 lead. Negative, we're not even going to configure. It just happens to be in the bundle. I should be using stainless steel because, yeah, the aluminum oxidizes and it also is soft. Plus 25 volts. I have to turn the output on in order to get the voltage in there. So I disconnect the lead. It's been a minute. Yes. I'm curious if you were ever able to fix the TB303 clone module. No. I had, you know, a break. I had like a nervous break while working on it because it seemed like I was constantly chasing functionality, and it seemed like everything should be functioning in one area, but it wasn't in the other. And then it got to the point where it's like, well, but in order to test that, I also have to induce a signal into this thing. And I don't have any great way to do that unless I hook up my whole modular synth setup. So instead of having that whole briefcase sitting up on the desk, we started to put this together, which is a module testing stand, basically something that I can put a module into and have all the signals that I would need in order to test one. We've gotten some very interesting results with this thing. I've been able to get 6 channels of any old signal out of the 6 outputs using I2S and a Teensy 4. So that's been really cool. There's going to be a lot more stuff to do. No, it's inspired by the Mutable Instruments one, but since the Mutable Instruments didn't have universal I/O, and I wanted to have universal I/O on the front panel, which I'm pretty much going to have, except that we're only able to measure 2 channels at once. And in order to get that set up to work, I had to put a bunch of muxes on all the lines. But we tested them. They work. I can use the Maxim product. So output on 25 volts. We take this up to 15. So there's our common Eurorack input voltage on this line right here. For display purposes, I'm going to try to hold this like this, and we're going to look for heat. We're going to look to see what's hot, because this is going to draw 1.5 amps from my... Oh, that's not going to work, is it? It's going to draw 1.5 amps from my 250 millivolt capable modules. Wait a minute. This is a bad idea. Well, I'm not allowed to change the results, so here we go. Oops, that's wrong. That's the wrong lead. This is the lead. Are you guys ready? We're going to do this quickly. Everything's going to heat up. These are going to stop functioning because the power supply is going to drop the voltage down. I've had to take many breaks working on 303s. They're soul crushers at times. Yeah, I've been going through it piecemeal, and I'm actually going to start powering down. When we get back to it, when I have something of a voltage module working, I'm going to isolate the stages of the 303 in order to get it tested up. Never used universal I/O. Basically, what I'm going to do is I'm going to have it configurable from the front panel. Let's just take a look and see what pops here. I predict that the power supply is going to drop down to nothing. Yeah, 0.18 amps and nothing is happening. Is anybody heating up? The modules are, because they're being asked to output too much. So what happens when... But that would kill the circuit loops. Wouldn't that kill everything? I take this out of the equation. So there's no current running through. Why did that make a little sparky noise? Well, nothing's happening there. Nothing's happening there. I am drawing 0.18 amp. I guess now I get to look at voltages sitting on the lines. I know you guys are watching to see if anything's heating up. Did I smell something? Everybody's still cool. Be cool, be cool, be cool. All right, positive to negative test. First violation. Oh, there we go. 15 volts. You guys can't see it. Okay, 15 volts there. Test from ground. There. All right, so we're not outputting. I don't actually think we're outputting anything. In and ground. This absolutely should be making a connection. Where are you getting 15 volts from? From my my Agilent over here. It's a very clean 15 volts. Maybe these aren't doing anything. The circuit doesn't work unless I have two power supplies too. Nah, no power splits on the breadboard, I don't think. Unless this one's unlike its buddies. I was about to say, cheeky bastard. No, it's definitely, yeah, okay. So that the 15 volts gets to this side. It might be that the pins of the power supply don't go all the way down. Oh, here we go. Okay, I need to go outside a little bit. All right, so turn this off. This goes here, and this goes here. The pins are all the way on the outside. Okay, So now we're ready for like an actual power test. Coworkers blew stuff up. Be right back. At least somebody gets their exciting explosion. All right, ready? 3, 2, 1, go. Now it's drawing less current. These things still aren't powered up. Yeah, still nothing. So I'm getting no power to the modules themselves. And just to double check, from here to here, hold on, well, let's test across these leads here to here. Nothing? Okay. I'm even not getting into this. This is not poking in as well as it should. 0 potential across all of these. Okay, neat. Coming from these two, this one goes all the way to here. And this one to here. Yeah, maybe these aren't connecting fully. No, they are. They are. I'm testing them on those things. Let's see, I gotta like push it down. Well, they're still not lighting up. Darn it. We're gonna have to go with no explosion just for the unfun reason. But I don't see what's not connected here. I mean, this should be working just fine. Of course, there's no load across the output, but I don't think there needs to be. Yeah, they have to have a minimum current draw to turn on. No, because they're supposed to get their own isolated power supply, which we didn't exactly provide here. And it would be across these two leads here is where we get our power supply. And we're not seeing anything there. Across this and this. Yeah, I'm not getting anything on those. So maybe my crazy circuit design, my crazy hookup guide was totally wrong. Or maybe we're just not getting a connection here. So like from here to here. Okay, that's negative 24. Wait a minute. That should be from, oh yeah, that makes sense. Okay. From here to here, it should be negative 12. Why is that negative? Wait a minute. So this is positive power, and then ground is this pin, and yet I'm getting negative 23. By all means, something should have blown up by now. They have a minimum voltage. Yeah, but I don't know if my diagram, I don't know if my circuit hookup is exactly great. Okay, I'm turning this off before it blows something up. I'm getting like huge voltages across stuff. That didn't work out at all. The point was to give 12 volt potential. So here I have red and yellow on plus 12, and then I have minus 12 going to ground. So that should by all means be 12 volts. And then that ground is our internal ground, but it's also the ground for this ammeter. And it would be the ground that would be returning from this positive 12 volts right here. And so the yellow wire is the measuring wire. That one goes up to that also positive 12 volts. On the second amp, we have it hooked up between ground and negative 12, because the potential there, in terms of plus and minus, if you shift it over, minus 12 becomes 0, ground becomes plus 12 becomes plus 24. So we would be giving 12 volts to this one, and then we'd be connecting the two negative wires here and be getting a measure of current returning to the power supply there. This should work. This should work. This should work. But in practice, it does not. It ain't doing anything. I mean, having the two grounds isolated in that way, they are kind of connected together, though. The commons eventually connect together when they get to the actual connection to the load. But again, I'm not getting anything on the meters themselves because I'm not getting voltage into the meters. And yet, I'm able to measure the voltages isolated from the little power converter supplies. They're a little bit cooked, but they're there. Sanity check. 1, singular power supply, positive 12 here, goes to, oh wow, I've ruined some of the connections inside of this board. That didn't feel great at all. That's not good. That's another breadboard down the drain. Black wire here. I hate that. That's what I'm doing right now. That's what I'm doing before you suggested it. Technically, that's positive power, so let's do... No. How does this work? It goes... This is the negative... Okay, so we've got our resistor here. Actually, let's make it 14. That's not going to give us 200... That's going to give us way over 250 milliamps, so that'll threaten to tank our power supply. But we'll take positive 12 here, and we'll put that... Wow, that's a very loose-fitting connection for that one. And we'll put it in here to positive 12. So that's just a straight connection. That's how this works. Positive 12 is also going to be our power supply, and it'll be our meter connection. Okay, some of these pins have ruined my prototyping board. That's not good. So like that, and then we'll take the tweezers, and I'll grab this little piece here and move it over so that it's on the other power supply. So red and yellow are connected. Red's really supposed to be an independent power supply. So if this resistor takes out this power supply by, you know, putting too much load on it and the voltage lowers, it'll take out my meter as well. But I don't know. I don't have much of a choice. So ground here to the black wire here. And then what is the direction? It goes black wire here to ground. And then red to the other side of the resistor. So that current flows from red to black through our shunt. Now, if I turn this on, this meter, by all means, should function. It doesn't. Why do you forsake me? Those are connected there. This is the diagram. This is the diagram. Push down on the thing. Wiggle it a little. What the heck? What the heck? Current is going through the module. The module might be shunting out. Pull this. Nothing. We're dropping down to 12 volts and I'm hooking it up directly. So get this one out of here and then turn off the power supply. And then we take these two, and one of them, the positive lead, goes to our red. Was that not hooked up? Maybe that wasn't hooked up. Because positive goes to, yeah, that might not have been hooked up. It goes there, and then positive, oh wait. Yeah, positive there, plus, 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 all the pluses. And then negative goes here. Some of these lines are completely destroyed. Okay, negative goes there, and then the return on the positive goes through the load. Okay, so now this is only hooked up. I need to unhook the power line and turn this down. Polarity check on the modules. Yeah, I did. Well, it should still work at 15 volts. So I'm going to take it down to 12. Bada bing. Wow, those aren't good for stream. This is reading 12 volts as 12 and a half, which is a little weird. And it's not reading any current, which is also a little weird. A little weird. Why are we not measuring current? There should be current running through this thing. That should be drawing an amp. 0.11. Hold on. Well, it seems like 12 volts isn't getting through, everybody. It absolutely should be. 12 volts is here. This one goes through here. There it is. There's our amp. Okay, so we're dealing with bad connections. I need to work on the connections in here. I think these wires aren't connecting properly. So I'm just going to put them on a header. Well, the PSU said it was outputting 12 volts, and this thing measured 12 and a half. I think we just have some bad connections here. I don't know why that would have made the module not... This is supposed to get an isolated power supply. Why would pushing down on this power this up? Wonky perf board. These are vastly different lengths. Yeah, that's part of it. The breadboard has all kinds of bad contacts. It's breadboard after all. You're supposed to have to deal with a little bit of this kind of stuff. But getting good contacts is just part of the game we play. Yeah, it's feature, not... Yeah, you know, that saved me from damaging stuff. I guess. This is why we do this. This is why we do this kind of stuff. This is why my desk is full of absolute bonkers mess, and why I have regular nervous breakdowns about being completely off in terms of the amount that I've accomplished. All just to vet out all this stuff. Yeah, you learn where to press down on stuff in order to get things to function on a breadboard, on a good breadboard. The problem is, you know, the last time we did the time before last, we did a breadboard circuit. It really pissed me off because my breadboards are getting old, and so I bought a bunch of new ones. But like when we do digital stuff, the old ones are fine. It's just when we do analog, you put an analog circuit together and nothing works. And it's built out of these flimsy little 1% resistors that barely make contact with the little things inside of the breadboard. It's just very annoying, but we're building very complicated devices, so we're in it for it. These are just temporary connections. Or just not connections at all. The strain of this thick wire is going to be a lot for the connection here. It's thick, cheap wire. My favorite. Ugh, I think it burnt the plastic a little bit on that. Oh yeah, it definitely did. Why is this like pulling up from itself? It's like, oh my god. What a mess. I'm probably going to have to find a larger resistor though, because 1.5 is going to be... Well, 1.5 amps is what we're rating the power supply to, aren't we? But it's only 250 milliamps for these modules, so I can't really... we're going to see a voltage drop from the module from the power supply module when we reach those currents, so it's not really going to help test things. I'm going to lift this up a little bit. This is an unwieldy soldering iron. I probably should use the wedge tip. Slightly more civilized soldering iron. For an age when people used to solder things. All right, whatever. Works for me. The Twitch UI told me to try this. Were you trying a conference call? Because it sure as hell doesn't come up on anything for me. I need to disable that new thing. All right, output's off. Everybody's connected. So now let's double check this. If I do 12 volts from here, I hook 12 volts to negative and the 2 positive leads, the sense lead and the other one. And then in order to sense the current, I need to go from -12, which we'll do with just a little jumper. So we'll go from negative here to negative here, and then positive across the load. Yeah, positive across the load to negative. So across the load. So from here to here. Which means positive is connected all the way to the load. Negative of the load goes... Negative load goes through here where it reaches negative on the jumper. And so if I turn that on, we get our reading of voltage and current. That's a little bit more consistent. That blinky is going to be really annoying for chat to look at. That may be the opposite of a selling point for me. I can see all the numbers, but you guys see madness until the camera meets up with it. But then if something interrupts that, my NoScript hates that thing. Not sure what it was. When my browser blocked it, it's just a warning over the message. The Twitch added something where you can collaborate. You can call into another stream. Yeah, this is the Logitech camera like syncing with it. I don't know if that's tolerable. I may have to go with a VFD for the whole thing. I may have to put another microcontroller in that's just going to look at shunt amplifiers and do its own thing. That means there's going to be more of a draw on the 5 volts, but... Oh, are these getting super toasty? Oh boy, load resistor. Load resistor coming in hot. We got load resistor here. I'm still not measuring amps, though. What's going on with that? Did I blow out my shunt resistor? Oh, I'm plugged into the wrong one. There we go. I don't know if people are going to be looking at it. So that's 1 amp, 12 volts. So let's see if we can get -12 running. So I'm going to do the output here, and I'm going to turn on -12. Turn that off. So now this lead is -12. Right now, this thing is measuring across ground. It's measuring everything across ground. Looks like ground is shared too, so you only need half of that. This is this is a problem. This is now going to be 2 amps. That's now 2 amps. And then we're going to have a connection across ground here. So ground is going to be connected to... Fuck! This thing, shot this thing across the desk. Ground is connected to the positive of the next one. And then the voltage sense is going to be connected to the ground. I need one more of those little jumpers, and I think I ran out of them. This whole circuit is now obsolete because we've already tested it. So it's getting torn up, getting toe up. Where's my jumpers? I thought I could do this with all this stuff right here. Maybe there's a little one-to-one jumper over here. My only problem is that I think it's going to be measuring both currents. Well, no, because it's measuring -12, but then the other one's measuring, so I need to, actually, this ground is, which ground is that? That ground should be the one that's coming in from the power supply. Yeah, so the power supply is measuring it all. The current sense is going to only go out to the device. But that shares a ground with -12. So wouldn't that be sharing the out, like the, it's going to be, it's going to be coming from that ground, going across the shunt resistor, no matter what. So that'll be a measurement of overall current. It's not just going to be a measurement of current from one supply that needs to be isolated. That's the problem. It's a little complicated, and I keep forgetting it. This ain't gonna work. I think I may have to find some kind of a shunt amplifier and make my own thing. In which case, I'll be able to use the VFD display, but it's a little bit much to have another display on this thing. Another big old display. Maybe I'll find something cool. 3 circular displays? What'll power that? Pico Pi? Only to do shunts? No, that's silly. This thing's still hot? It's still hot. Well, it's about to get hotter. And then the black wire goes to -12 with its buddy over here. And so this would be coming back. We go to the red wire. And then we go from that wire to, from the one next to it rather, to -12, to this line here, and then -12. -12, -12. Now, is that going to work? Because this is essentially now my diagram. This is the diagram that we made. 3, 2, 1, explosions. Well, one of them worked. 7 volts. I think this is killing it. Oh yeah, because we're down to 7 volts over at the power supply. This is no, I need a larger resistor. So did it explode? I'm gonna go with no on that one. How do I do the poll? How do I undo the poll? Pop out chat, edit layout. All right, fine. We'll give it a little longer. Okay, so I need a smaller load. I need resistors that have higher values and still have a predictable value. I have 6 ohm resistors that are in big armored containers. I could juice this all the way up and allow undo the current limiting on this thing. I don't know if the current limiting is even on. Let me check. Gotta unplug these from the supply and just figure out what they're 12 volts, 1 amp. 1 amp. Oh, it doesn't go above that, I don't think. How do I get over there? No, it's display limit. Oh, current, there we go. No, it doesn't go above an amp. That's the limitations of this power supply. How do I get out of here? Okay, there we go. All right, so I can't go over an amp, so we need to bring this down. So I need something like 12 ohms on each of them. I don't have any armored 12 ohm resistors, do I? If I put like a 1K on it, that's going to be, what, 0.12? What other big resistors do I have? Let's see. I don't really think I have. I only have 2 more 7s. If I do 14, that brings it to an amp, and that's the maximum that my power supply can handle. But I guess we'll do that. I'll double them up. Let's double it up. Need like a precision 10K. I don't know who bent the leads around like that. It's a weird thing to do. Although it does come in handy for us right now, because then I can do one like that and the other one straight. I can just solder them together. Shunt resistor. Solder. Okay, like that. Now it goes to here. Nice and easy. All right, there's that one. Let's get this lead back over here. I used to have all kinds of big electronic stuff, but I kind of got rid of it with all the moving that I did and all that stuff. Going digital means I don't need all the big weird things that I used to hoard. Though I really should have, because streaming, having stuff that's interesting is kind of a nice co-host. Where'd the other one go? There it is. So all kinds of like old science stuff. What I really need is one of those big rheostats with a knob on the top, or whatever they are, the frequency drives for AC stuff. I don't really need it because I don't really do much with big AC, but if I ever did, I would want to have something like that. It seems like most of the sciencey people have one. Which is a really good excuse for buying gear, but whatever. Whatever, everybody else has one, Mom. Oh, well, here's a dog barking in the neighborhood. He has to answer in kind. They got a whole dog network of puppies that we let play. Because we have like a little cul-de-sac that's relatively isolated, so we're able to let the dogs kind of run around. All right, so that should be 1 amp. My power supply should barely be able to handle that. And so we should see both of these screens. What's this one? Both of these screens turn on. This one is positive 12. This one is negative 12. The potential for explosion is still present, but what I'm predicting will happen, and we're not going to do a poll for this one, but what I'm predicting will happen is this one's going to say 2, and this one's going to say 1. And that's because all of the metered stuff on this one is going to be going through that ground connection, and this one's only looking at the minus 12 line. So if theory is correct, if I could find a power supply like this that will measure the positive, that would be great. It would be nice if we could see what chip was in this thing and see what other kinds of circuit diagrams it was involved with, but it looks like maybe it's some kind of a universal part, or maybe they just found a better part or made their own. I don't know. Let's see. 3, 2, 1, go. Son of a bitch. Why won't you turn on? Why did I hear a snapping noise? Oh, because we're dropping. Yeah, we're dropping down pretty far. Darn. Yeah, so the 1 amp current limit is coming into play here. And that's gotten pretty toasty. I need bigger resistors. That's just the way of it. That or, you know, can we get 0 reading off of both of these? I don't know if it works that way. Let's just disconnect 1, 2, and ground. Disconnect that, and maybe both screens will power up. Yep. And they're both reading voltage as they should, although this one's a little cooked. Let's give them like a small amount of current that we can measure. $1Ks are going to explode, aren't they? I mean, 7 ohms is what we were doing before. These are not super duper robust. So let's go down to 470. We might as well. Let's measure an LED. That's essentially what these will be doing. So 470 ohms, and so we're going between positive here, which is positive voltage, and then we go to ground, which is over here. Jeez, I gotta watch where I'm plugging these things in. Third pin, ground, right there. Here's that one. And then the next one goes from the positive pin here, which I don't want these to contact one another. That would be bad. To positive 2, and then negative already goes over there. So I need that one to go to negative 12, which is all the way over here. Okay, so whatever 1 meter reads, the other is probably going to read double. 3, 2, 1, go! No, we're not reading anything. Damn it. God, that's so chaotic, that the flashing. All right, so we need a much smaller resistor. Maybe we'll go to the single digits, and we'll go to 70. Well, 75 would be 0.1, so 100 milliamps. I think. Wait, no? I don't know. Oh my God, Will's going nuts. So from here, which is, this is the positive rail. Oh, that wasn't connected very well. So that goes to ground. It's tough to get to. And then the next one goes from ground. Similarly goes from ground to, or no, it goes to the negative rail there, but then here it goes to ground. Oh, maybe I had it connected wrong. It's like I gotta get to either side of this other wire. Okay, so there. So from negative rail through that resistor to ground, and from ground through this resistor to the positive rail. Well, through the shunt resistor to the positive. Okay, all right. I think that's it. As confusing as that is. If I turn this on, we should get 10. Damn it. Why did that not work? What happened? On the positive rail, we're not going from plus. Sorry, this goes through ground. This goes to here, which is positive. And this goes to, oh, it wasn't plugged in all the way. That was the problem. Can I move that? Yes, I can move it. Okay, that's going to go up here. There, now I've got a clear path. Damn it. All right, what did I mess up? Positive power here goes into here, and it also connects here, and it goes over to here. Positive power goes through the shunt because it's the load, and then it goes to positive. Wait a minute. No, that's supposed to be measuring across ground. So really, it's supposed to be, well, but yeah, the load goes from positive to negative. So if positive is coming over here, why is that like half plugged in? Weird. Positive here goes into there, goes to all this mess over here. Not this one, the one next to it. Positive goes to our shunt, and then through the shunt, we measure what's coming back on the resistor. Positive should go to the shunt. Wait a minute. That's wrong. This is wrong. So now, why are these in the same? Jeez. That one goes there, and then it goes to plus, and then this one goes to minus. That's what I'm missing. What is that one doing there? This slipped out, and it went to the wrong... Okay. Those two are going to... No, they're going to the wrong one. Okay, all right. Brain? Can we rebrain this? Can I figure this out? Break it down now. Everybody go away. Everybody goes away. We start over. This time, I'm taking my shunt and I'm making it elsewhere. So I'm going to make these leads stand up way far from the breadboard because there might be quite a bit of current going through them. And I'm just going to put them over here. And since this is a dual supply, we have dual shunts. I keep saying shunt, and it's kind of lost all meaning. But I'll have one there, and I'll have one here. And that is in a go-hot zone where it can get all toasty, and I don't care. No explosions yet. Put away our resistors. We should be able to see current. We saw current on the one that was connected properly. I'm just taking this on an individual basis now. So, one lead of our shunt goes directly to 12 volts. And the 12 volts is also shared with the 1 meter that's metering 12 volts. And it's not shunted. It just goes straight over to 12 volts. So one lead here, and the 12 volts is coming in here, where we're measuring it. And I'll put it over to here. Okay. Then, the next lead of this thing is going to go through a shunt. So, from here, we go through our positive shunt on the red wire. The next lead goes to the other red wire. So that's here, other red wire on this lead. And that is the connection of our supply. The black wire from the one goes to both of the amps black wire. So negative 12 here goes to the black wire here, as well as the black wire here. So I need to go across all that stuff. I'm going to go vertical just because it's cleaner. Not easier to work on, though. But it goes to here. Okay, so there's that. Next, the red and yellow from this one. So that's red, yellow, and black. All three of these pins are going to the power supply ground. So all I need to do is push that right there. Power supply ground, all of that is connected. That also connects to the red wire of This one. What? No, that's not right. Hold on. Positive there goes to there. This one, red wire, goes to, yeah, ground of this. And then the red wire also connects to these two down here. Okay, so let's get a wire for that. It's so confusing. So red wire here to ground here. Although I'm not still hooking up the same diagram, so does that still stand to reason? Hold on a second. I'm following my other diagram. I think that's the problem is. It's hold on, you're barking up a different tree than I am right now. That's a different thing that I'm working on right now. No, I'm following the wrong diagram. Is this diagram still, I don't think it still works if I do all that stuff that way. So let me just, I'm going to start over. The first power supply, I want it to be connected to positive 12 and ground. So positive 12 going here to the red and yellow wire, and then ground is because it just needs the potential running through it, ground here. And so that is the first one connected without measuring current. Current is coming back on this ground line here. And again, my theory is that that's going to end up being double. But so current goes to the red wire, and then the black wire goes again to the ground that we hooked up to all that other stuff. So this one, negative, that one goes to this whole big cluster of ground objects over here. The next meter is measuring from ground to negative 12. And so the measurement lines are on ground. Negative 12 goes to the negative line, the minus, the lower potential line. Jeez. So then coming from the negative line, we come out through minus, we go to the plus of the current monitor, and then from the minus of the current monitor, we go to the ground of everybody else. That should be everything hooked up there. I had to get rid of the diagrams for a second and just go by the seat of my pants. That's what I'm doing right now. That's what I'm doing. I'm proving that the circuit works. All right, well, I got that one working and not its buddy. Why are you not working? You are going between minus 12 ground, and this is ground, that's ground, and that's ground. Why are you not working? Y'all plugged in? Seems to be. The potential between those two is going to be 12 volts. Whoa, and then everything falls out. Hold on a sec. My breadboard's, the state of my breadboard. Perhaps I misjudged you. Maybe this needs to be reversed. The black and the red. Well, no, because it showed the same way on the other one, too. On the other diagram we saw. And the other diagram we saw was fine. Positive going in through there, out there. Then we've got positive, positive. It's all positive. And we've got negative, and it's a huge cluster. Negative, negative, negative. Everything's negative. And then that with the shunt goes out to this thing. There's the current thing. And then the center wire is the one that's being measured, which goes back to, again, all the negatives. Those two are on the negative. That one's on negative. By all means, this should be powering up. And yet, minus power. Whoa. Okay, it's drawing over an amp for minus power. Oh, geez, what's going on there? That's a hot tamale. Whoa! Plus 12 is super hot. Woof. Smell that. All right, what did you did? What did I did? What did I did? Minus going to all three of those elements. Maybe it's the lack of isolation of power supply that's getting it. Because like that should not have been out. And it was drawing it all from -12 for some reason. And this is the only, this is -12 right here. And it connects to just the black wire. So I probably lunched the meter. Is anywhere really to short stuff out? Positive, positive. Does it go directly to negative? Positive, positive, and then red to black, and then back to ground. No, this is the man. We got one meter working, and then we got the other meter kind of working. We sort of got them working together, although they weren't measuring current at the time. And then I locked down the leads so that they were measuring current. And then chat tells me to check to see if the individual components are working, which is what I just did. The whiteboard thing that I thought would be my savior, this is essentially how it's hooked up right now. It's just for some reason the one shunt, the one load is really heating up, and we have all of that ground going through one of the meters. So it definitely would read double if I got this to work at all. I don't know what exactly is broken though. It seems like our positive voltage, or sorry, our negative voltage is overdrawing current and dropping down in volts, and so the meter doesn't turn on because it's dropping way down. So I don't know what the cause of that is. I need to look up a little bit more into reading current, I guess. I thought that was a much more trivial thing to do. You just voltage drop across a resistor. But I'm striking out. I'm striking out, and I don't like it. And it's getting on in hours anyway. We've had a pretty good stream today. This has been a Wednesday. It's a rare Wednesday stream. I think we hit 65 people, which is nice. I shouldn't be so concerned about numbers. I talk about that too much. But, you know, I've had an eye on it over the past couple months because, you know, things have been weird in my life, and I'm afraid that I'm sort of losing grip on all of my viewers. But the more I try to grasp them, the more they ooze between my fingers, because you guys are made out of Jello. I'm going to be back tomorrow. We're going back to back today, so I don't have time to order parts. We'll either figure out one of my own current shunts and involve a microcontroller, which is not what I want to do. I don't want to add microcontroller and complexity. My back might be against the wall in this case. I don't know. I'm not sure. But boy, it'd be funny to put like some kind of a decoder on, like redo the circuit on these things. They multiplex the LEDs, and I don't like that. One LED on at a time. And when you put that on camera, it just looks bad. It looks very bad on camera. But I mean, if I want to have this mad flashing thing, I don't know what the VFD is going to look like either. So it's possible that we work on screens tomorrow. Maybe we hook up a 5-volt power supply and we start poking at the screen and see what that looks like. But anyway, I'm going to be back tomorrow, so I will see you then. Here's the end card. I believe everything in it is accurate. I'm ending kind of abruptly because I don't want to mess with the circuit anymore. I don't want to mess with the circuit anymore. It's confusing. And I'm not really sure if I can get it to measure proper current unless it's measuring two lines at once. There's no individual grounds in a Eurorack system. If I plug something in, I can't isolate the ground just coming off of -12 volts. I can measure through -12 volts, so that actually makes these viable. But I can't measure positive, the current running through just positive 12 volts. I don't think. They say I can't do that, and it'll blow up the meter if I do that. So I might have blown up a meter. I'll have to test that. Maybe on my own, maybe when we get back. But yeah, it's so annoying. The whole script got flipped on its head today, and I had to then kind of like maneuver what we would be doing around that. And I think we had a bunch of success, but at the same time, it's just been kind of a little topsy-turvy. And this happens. This happens with this kind of stuff. I think anyone who wants to start off in electronics should not get the false impression that things just kind of go over smoothly as they do on YouTube. So I'll have to take a look and see if there's anything like this. There has to be this kind of, oh, the current will definitely double. I mean, everything is loops in electronics, right? I don't think we're going to have a positive to negative 12 volt loop. But, all right, anyway, I will be back. Here is the end card. Well, I have to go take my dog out because she's barking at all the other dogs in the neighborhood. But we'll be back tomorrow. We'll work on more stuff, and it'll be interesting, and we'll have arguments. I'll see you then. Take care. Where's my, I said take care already. We're done. Like I said, take care, and now the scene's not changing. And so I'm sitting here out in front of everybody. I've got like all these people looking at me just kind of flounder. Like I don't know what to say. I don't know what to talk about. It's like I don't know how I can stall fast enough.